Welcome to Global AI Bootcamp Bulgaria. As you know, yesterday and today we have many events worldwide. This is a global initiative supported from Microsoft and Microsoft AI community related to different events in the same timeline worldwide. In Bulgaria, we are organizing this event online this year, and you will have 5 very interesting sessions in the next 6 hours. We will do the best to have really good content and hope that you will enjoy this conference. We will appreciate your feedback and we will ask you for feedback how to make events better next time. Please follow our website and our Facebook page for the next events which we will have in the year, because this is not the only one AI conference which we are organizing. So I hope that you will have a great event, enjoy the conference, and let's session started.
Hey everyone, my name is Sami and I'm an AI MVP based in Belgium.
Hi, my name is Sjoukje and I'm an RD and an Azure MVP based in the Netherlands. And today we want to welcome you to the Global AI Bootcamp 2022. And this is the 4th year that this event has been organized globally. Our mission is to connect AI communities across the world to share ideas and content with each other. Thank you so much for joining us on this mission. The Global AI Bootcamp is organized by many different communities across the globe. And therefore, we want to thank each of them for all their hard work and passion as community leaders.
Today, you're all together virtually or physically to get inspired by the latest AI technologies and trends. This might be by a workshop, talks, or hands-on labs that your community leader has prepared for you. Today is all about learning new things about AI and sharing knowledge with each other. We hope that you can apply this in your work, in your community, and even in your daily life. Now, there's a lot of interesting stuff going on in the AI space, so we would like to invite our friends from Microsoft to go over some of these interesting topics.
Hi everyone, welcome to this Global AI keynote. My name's Amy Boyd and I'm a Senior Cloud Advocate here at Microsoft. I am a white female with long wavy blonde hair, and today I am wearing a black top with colourful spots on it, which sounds very exciting when I describe it like that. It's not quite as exciting in real life. So it's so great to take part in the Global AI community and the Bootcamp initiative in January. Thank you so much to all the organisers for having us along to speak about AI and accessibility. We're really excited for what we've got in store, and so without further ado, let's get started. I'd like to introduce Saqib, who is our expert for today around the focus of AI and accessibility. Hi Saqib, how are you doing?
Hi Amy, thank you so much for having me. I'm doing great. And I guess my description of myself is I'm a middle-aged British Asian male with short black hair wearing a blue shirt.
Wonderful, thank you for sharing that with us. Saqib, me and you used to work together way back when. Oh my goodness, feels so long ago now. I was an intern. You introduced me, you made me feel very, very at home in the Microsoft Bing team over here in the UK. And I had a wonderful year on my internship. So thank you so much for that. It's great to be working with you again. I know you, I know what you've been up to and have been watching along, but for those who don't, can you tell us who you are and what you do at Microsoft?
Yeah, those are fun days for sure. So I'm Saqib Sheikh, and I lead a team of engineers here at Microsoft working on solutions to empower people with disabilities to do even more, powered by emerging technologies like AI and AR. And in particular, we make the Seeing AI app, which maybe we'll get into later on.
Yes, now I'm sure we will, but drop that in there to keep people watching, which is great. So when me and Henk host a show actually called the A Bit of AI Show, and something we do in there is called the quickfire questions round. It's very exciting, and I'm quite excited to do a shorter version with you so that our amazing Global AI community watchers can get to know you a little bit better. So are you ready for a few quickfire questions?
Okay, let's give this a go.
Wonderful. Okay, so what was your first programming language?
BBC Basic.
Oh, wonderful. That's what we like to hear. What was the programming language you last used on the project?
C# and Python.
Interesting. Two popular choices. And our third question is, what was your first computer?
Ooh, yeah, that was a old Toshiba laptop many years ago now.
Oh, very nice. A good one to shout out. I was going to say, I think, yeah, I went from I could only remember what operating system my first computer was. So no, very good for even getting on brand there with a brand name. Thank you for sharing. So there are a couple of our quick fire questions to get people to just know who you are, your background, you're incredibly technical. On that first computer, I wanted to ask you a little bit, if we could dig into what were some of the accessibility features you were able to use then, and kind of how have things moved on a little bit now?
I think in many ways, the fundamentals have stayed the same. As someone who's blind, I use a screen reader, which is a piece of software which runs in the background, and it looks at what's going on the screen, hooking into different APIs and speaking out loud using text-to-speech. And that in many ways was the same decades ago, and that is still the fundamental today.
Oh, I love it's so interesting, isn't it? Because actually, like you said, if there is this, the fundamentals, and then I'm assuming everything just makes everything slightly easier. I guess it's like that for any tech, though, isn't it? Everything just gets better and better and better, hopefully, in most cases. Following on from that, I was wondering, can you share your perspective on why it's important for our audience to make things accessible? A lot of people in our audience are building different things, and I'd love to hear it from your perspective.
So you say accessible, and clearly accessibility is my passion, but I'd also invite the audience to think about inclusive, because on the internet, your audience is everyone. And out of 7 billion people, there's 1 billion people with some form of disability. So if you want to include everyone, then actually, there's a whole lot of people with different needs. And how do you meet everyone's needs? And so the interesting thing about this is it's even bigger than that, because there are people with permanent disabilities, sure, but then also situational disabilities like having the sun in your eyes or a loud noise in your ears, and temporary disabilities like, just breaking an arm for a while. So you want to be inclusive of everyone. So how do you do this? The big way is to be conscious of who are you excluding. And if you know who you're excluding, then just think about how can you include those people. And even if you can find 1 or 2 examples of people you're helping, make sure you laser focus. We often say design for one, solve for everyone. And so, yeah, you focus on that and you will include everyone, and you'll be able to make way better solutions as a result. So accessible, inclusive, definitely.
It's such a good highlight. Thank you, Sakib, for sharing as well and breaking it down, because you're right. Like, you think what 1 billion people, and oh my goodness, that's a lot of people. But then you've really broke it down into a few categories there for people to consider, which should make it a little easier for people to go, okay, yeah, who am I excluding and how do I solve for that problem? Really like that approach. Thank you for sharing. One of the other questions kind of looped in the AI element, because I know you're very passionate about AI and accessibility, are two key topics here, and bringing them together. What tools and services are making the biggest impact in the AI and accessibility space? Probably thinking from the bigger picture.
Yeah, so deep learning, as I'm sure the audience knows, is really improving every year, faster and faster, more and more. And if you think about people, I was going to say people with disabilities, but technology can really close that gap. So it's less about disability and more about, have you got the right tools to close your gap? Like for people who are blind, we now have computer vision tech that can recognize what's in images. And that's what our Seeing AI project is about. For people who are hard of hearing, we've got tech which is getting better each year at understanding, taking a stream of audio and understanding individual sounds and being able to alert on that. Or for someone who can't speak, we've got custom neural voices. So people are working on banking your voice while you are still able to speak. And for people with neurodiversity, then there are ways to transform information into a way that is inclusive for you. And the list goes on and on and on. But it's this idea that, okay, we can use AI to figure out how are we going to present this information that is inclusive of everyone and our individual needs.
Yeah. Oh my goodness. And you really rattled through there a whole set of AI technologies that have really come on leaps and bounds as well in the last few years. Computer vision, translation, text to speech, the neural voice stuff. I mean, it's phenomenal in some sense, isn't it? What we can do with some of these technologies. Can you tell us a little bit more about the Seeing AI project? You touched on it a little bit there. Can you give us a sort of overview for those that don't know about it and actually maybe where they can go and find it?
Totally, always happy to plug. So it's called Seeing AI, and you can get that from the App Store, or go to seeingai.com. But this is a talking camera app. So for someone who's blind, you can just point your phone at something, select the channel, which lets you know what task you're interested in, and it will read things to you, recognize the people around you, and describe objects and so much more. Let you relive your memories in your photo gallery, or even recognize photos from other apps. And yeah, it's a really popular app amongst people who are blind. But we're always looking at it's like a conversation with the blind community. How do we understand the needs, find the latest technology from our scientists at Microsoft, and bring those two things together? So some of the recent work we've done was in augmented reality. So when the very latest iPhones had LiDAR scanners, we realized that now you can actually not only use computer vision to recognize what's in front of you, but know how far away it is and build up this 3D model of the world that persists over time. And we can use spatial audio to hear where things are in the 3D space. So you'll hear the word chair coming from the chair, or you could place a persistent audio beacon on the door. So it's like a virtual sound that comes from the door, and as you move around, you can hear that sound in 3D space. So these are just some of the cool new experiments my team's working on. And yeah, there's so much more, but go and check it out.
Oh my goodness, that sounds amazing. Love the idea, yeah, of the AR kind of space, and the chair, like telling you it's a chair is genius. Interestingly, I think the first time I tried on a HoloLens, I tried like the space experience, is it? And the directed sound that they had is really, really interesting, because like you could like lean one way towards the sun or something like that, and you could like hear it crackling because it's obviously so hot. And I was just mind blown in some senses. So really impressive to see what we can do, not just with AI as a a cutting edge technology, also with AR, with augmented reality, and stuff like that. So yeah, really, really exciting stuff. We'll have to catch up with you every year and see what your team is doing so that we're the most up to date. But yeah, go to cnai.com to find that, or go to the App Store. Sakib, before I let you go, we've got another couple of quick questions for you. I'm a big AI fan, but sometimes we know that AI doesn't always help. And so I wanted to ask you a very sort of blunt question, if I can. Has AI helped with accessibility in recent years?
Absolutely. There is no doubt that it's really revolutionized what is possible. But it's always worth understanding that AI is just a tool. So are the image descriptions that AI can generate, are they 100% accurate all the time? No way. And, sometimes I'm frustrated how slow the progress is, even though it's incredibly fast. And so sometimes people seeing AI and they're like, wow, you can just get an accurate description of everything anytime. And that is the vision, that's the goal. But it's worth knowing these are tools. And I think of this as we should make AI tools which help humans make better decisions. Because at the end of the day, let's keep people in the driving seat. And as the tools get better, you'll get better awareness, better knowledge, but yeah, humans first.
Oh, it's such a good point. And actually, interestingly, me and Henk always talk a lot in our show about the end-to-end of AI is so important. And as you said, like, how is it helping to solve a problem, make things easier, make things more efficient, is the center of everything that we do almost in technology, isn't it? How do we make things better? So I really enjoyed that perspective that you shared there. Kind of focus not just on the tool, not just what the tool delivers, but also what's the experience for the person who's using it and what decisions can they make from it. That's really, really good stuff. Wonderful. Well, to wrap up, unfortunately, we only have a short amount of time with you. As I said, we'll have to have you back. We'll have to have a catch up in the near future again. For all those AI experts, engineers, enthusiasts that are watching us here at the Global AI Keynote, what's the one thing you would suggest they do next to either learn more about this space or take action?
I would say solve meaningful problems. So find a problem you're passionate about. But then, this is the important part, find someone facing that problem, whether it's someone with a disability or someone who is, I know, accountant, lawyer, doctor, whatever your field is. Find someone who needs your tool and then work with them really closely to see how does AI work for them? How do the solutions empower them to do more? So I always say that when someone with a problem and someone with the ability to create come together, that's when you get magical solutions out the other end. So go do your stuff, and I can't wait to see what you put into the world.
Wow, what a wonderful way to end this this keynote for the Global AI community. Sakib, I just want to say a massive thank you for joining us and spending some time chatting to us about your insights, your perspectives, and your expertise in this space. We really, really appreciate it. And so with that, I'll hand it back to the amazing Global AI community organisers.
Thank you so much, Amy and Sakib, for this great interview about AI and accessibility. Accessibility is not just something small that we can push to the end of our backlog. Now let us investigate how we can help everyone by making intelligent AI applications.
Today, you can look forward to a great schedule that has been set up by your local community. So with no further ado, we again want to welcome you to the Global AI Bootcamp 2022. We hope you enjoy this day, learn lots of new things, and connect with each other. And of course, we hope to see you again at our next Global AI event as well. Enjoy the event.
Okay, hello everyone. Just to get a confirmation that we have everything fine with the microphone.
I can confirm. You can start.
Okay. Okay, thanks. Well, welcome to the Global AI Community online event. We're going to talk about forecasting time series. And yeah, we're going to start with some introduction first, then bit by bit get through the content. Okay, time series are a sequence of data points that are ordered in time, and the quality of the predictions are evaluated only in future due to some temporal dependencies on the previous data points. First of all, I'm Ivan Andreev, solution architect at Interconsult Bulgaria, also Microsoft Azure MVP, and CTO of ICB Digital. Mostly, I'm interested in our team is working on industrial Internet of Things solutions and machine learning as well. And let us say, if we have any free or spare time these days, I'm also specializing in assessing projects on some publicly funded programs. About our sponsors today, you know, the sponsors are helping us make these events free for attendees. This time it's Microsoft global event, and you know, when we are meeting in place, hope to see you soon in face-to-face. It is advertising, recording, streaming, and coffee, beer, lunch, and community stuff when we meet face-to-face. Michiel, on the opening, mentioned about our upcoming events. Stay tuned for Global Azure, which is going to take place on 14th of May. On the presentation, which I'm going to upload later on in SlideShare, I'm going to, you'll be able to follow the link, but nevertheless, you would be also able to find in Eventbrite and Sessionize if you want to submit a session or book a ticket. Okay, now we're starting with our content with, you know, wise words from some cool guys from the past. This is a quote from Albert Einstein, which probably most of you know. It says, "The definition of genius is taking the complex and making it simple." So you probably know that one, and sometimes restate it. Will be, and we all love simple things. We love simple answers to complex questions. Of course, we like when doing programming, we like single methods, packages, and apps doing a magic with just a single click or so. Or we'll have to explain what is happening in the reality with some triangles, 80 to 20 ratios that are explaining all the odds. But these are words from the same genius guy saying that the true knowledge comes with deep understanding of a topic and its inner workings. So what are we going to talk about today? The point is that most of us are not in the position of the user who wants just 3 buttons. We are on the position of the developers who need to make the things simple for the user. We need to apply artificial intelligence or machine learning. You know the joke about the difference between these two, that artificial intelligence is if you have it on PowerPoint presentation, and machine learning is if you have it on Python. And we'll talk about how time series forecasting works, so that you see how the seemingly simple methods which you use in the advanced technologies work, and know how to set hyperparameters and tuning. So the session is about making complex things simple in the area of time series forecasting. This is our agenda for today. It is online events are challenging because there is a lack of feedback from the audience, questions or so. But yeah, if you in some way manage to reach me asking questions, I would love to have myself challenged to respond and comment back. About the session, we're going to make an introduction about what's time series, what is forecasting. We're going to go through certain amount of technologies like MLNet, Azure ML service, RIMA and auto RIMA, regression, even Facebook profit, and we'll try to leave some time for a demo, although the content is quite extensive. I intentionally put the takeaway slide in the very beginning, just that you have this in mind and have further reference when we advance with the presentation, and have a confidence that you will be able to quickly find information on critical content. So you have a couple of links about time series, what is hierarchical time series, overview of certain forecasting models. Is just overview without going into depth, and time series analysis with Python. We're going to talk about RIMA, so it's good to have handy some sources that are giving you some basic explanation about RIMA. On the internet, there is a lot of content which is too high level, or one or such that is with too many details. So I have tried to prioritize content that is more intuitive to understand, and you will quickly give you a better level of understanding. The second link is a video from YouTube explaining RIMA, auto RIMA, profit, and regression. SSA, we're going to talk about it, its implementation, MLNet, a brief introduction to it, and a link to Microsoft Docs about end-to-end scenario with time series analysis using MLNet and SSA. And Facebook profit, it's something quite new, probably one of the most recent developments that are widespread out there. So what is Facebook profit? A quick start, a time series analysis using Facebook profit, and some improvements to make an assessment of the models and make your Facebook profit predictions better. Okay, now the real content starts. So what is time series? A sequence of observations that are taken over time. So the future is being predicted, but all prior observations are almost always treated equally. This is what is specific for a time series, and this is having quite a business value, because forecasting is usually used in planning, procurement, and its concepts are applicable to really many areas, business areas. So data in time series forecasting are temporal, meaning that probably the only thing which you have in data is the important fact that one data point is close to another. This is what is important. To the right, you see how a typical time series look like. You see, it's something like just a date and a value. It's not like a regression algorithm when you have multiple other features to use a label, a numeric label to predict. You just have time and data, and quite often this is the use case. And regardless of what we're going to talk about the next nearly an hour, the interesting thing is that the data is what it is. In one way or the other, you need to do your job by trying to predict something. We have such a scenario, such a use case at work, where we have to predict water consumption, hot water consumption from households for which we do not know, or we must not know anything in addition. So probably the only thing you would know is things like temperature or region, but it isn't helping a lot. So we have to predict with what we have, and we have at that date, at that time, such amount of hot water was used. At that time, that date, at that time, this is the amount. And now we want to predict what is going to be the usage the next day, like that. In time series analysis, we're focused on understanding time series and making mathematical models. And these models are of two type: univariate or multivariate. Univariate use only the previous values of time series to predict future values, while multivariate uses other features to predict values in addition to the time series. It's traditional for time series forecasting that the explanatory power is not high. It's really often low. You have a prediction, but it's difficult to explain why the prediction was that. So we're going to get into the depth of it and see how this works, so that when you use these seemingly simple methods with tens of parameters, you know how to set these parameters, and you know how to what to expect, and how to probably analyze your data before starting work. So the practical use cases, we mentioned one from our experience. Of course, there are many more, but typically data come from sensor readings, from medical data, from financial market. So these sensors could be environmental data like temperature, pressure, humidity. It could be IoT scenario sensors. Medical data could be of some appliances like smartwatches. It could be pulse. It could be heart rate. Probably everything is having certain predictability. Probably you get up in the morning almost every week. Every Sunday you probably get up at 10 o'clock, but every Monday you probably get up at 6:30. You probably get back from work almost often at 7 o'clock, or you work from home and you don't have significant deviations in certain habits. But you could probably see from yourself that only by observing your uptime, like pulse or heartbeat, we could predict what is the time when you get up a certain day. It's just an illustration. So sample scenarios are unit sales, how many items you have sold from certain type, number of passengers going through a train station, users on a website. You could even go for predicting your body weight over the year. You probably have 3, 4, 5 kilos more during December, beginning of January, and probably 5, 6 less in the beginning of the summer, like that. Time series come in various flavors. So there's few different types of time series. It's interesting to mention hierarchical time series here, and these are time series where there is an evident hierarchical structure. If you see, like we're in Bulgaria, so Bulgaria is split into south and west, and Bulgaria south is split into Burgas and Varna, which are two of the largest cities on the coast. And west is, for example, Sofia, for a simplistic model. This is an evident example of hierarchy. The elements are nested. With group time series, we have multiple not nested levels, and these groupings could be by category, by some thing like color. With hierarchical forecasting, we're not using any specific new methods. We're using collection of techniques. So the forecast shall add up. So what we forecast here for Burgas and Varna should add up to Bulgaria South, like that. So the approaches are bottom up and top down, first of all. The bottom up from the most granular level of the hierarchy. We start from there and aggregate with this approach. No information is lost due to the aggregation. but the relationships between the series are not taken into account, and this approach is not very suitable for highly aggregated data. It's interesting to mention here that there is in AutoML, the Python SDK, there is a method which works with hierarchical time series. So just have this in mind if at any point of time you need it. The top-down approach from the top level, you could split into more granular series. You start from top and then you split, but you're having loss of information on lower levels and loss of accuracy, of course, because just imagine Burgas are selling more than Varna, and how do you know how and when to split and what to wait to put on that split? There is also a mixed approach, which yeah, bottom is not. This is not the proper way to write bottom, but yeah, it's a typo. Bottom up from the middle and above, and top down below. And there is another more advanced way, which is called reconciliation, where each level independently is predicted. It's unlike the forecasting on the single level and then propagating. It's forecasting for all of the levels, and it produces more accurate forecasts with minimal information loss, but it doesn't work well when we have larger complexity. And the coefficients when splitting and making reconciliation is determined using linear regression. So you could see that things start becoming more complex slide over slide. You have probably heard about the duck test. It's a cognitive test saying that if it looks like a duck, swims like a duck, walks like a duck, it has all the not parameters but behavior of a duck, and it should be a duck. This one is often used to explain that if you observe someone's behavior, it is sufficient to classify what it is really. So the test implies that a person can identify an unknown subject by observing its characteristics in some sense. So with the time series, we have to ask ourselves a couple of reasonable questions. First of all, do we have enough data? So more data are giving us more options for aggregations and for tuning the model and picking a period to train. The next thing is the horizon for prediction, and it is obvious that we have higher confidence with shorter time horizon. Like I have your behavioral data from the last 1 year, and I could with greater confidence predict for about a day or a week ahead, but I could hardly do this for a year ahead, for example. Of course I could, but there will be really way, it will be, the predictions will be really way off. With the forecasts, we need to know whether we should retrain as soon as new data are available. The frequency of the forecasts, downsampling and upsampling could affect the accuracy in both directions. We have had such case where we have data every 2 seconds and want to predict something. It was voltage, and the voltage was going up and down, and of course we could not make such a precise model. So at some point of time, a straight line was having better prediction than whatever we tried. Then we tried to aggregate data at a period of a minute, 10 minutes, and 15 minutes, and this immediately led to extreme improvement in the predictions. So downsampling and upsampling of data could give you, but of course you could downsample if you have sufficient amount of data, which is 0.1. And if the time series is stationary, we're going to talk about a lot on that topic about stationarity of time series. But for that slide, just in a single sentence, this just means that the time properties do not depend on the time at which the series was observed. So in depth about the time series stationarity, because it's one of the most important things behind time series forecasting. The rule is if the time series are not stationary, data are not predictable and cannot be forecasted. Of course, they could, but there will be a deviation. So yeah, of course, we could always make some kind of prediction, but it's just going to be wrong. The point in machine learning and artificial intelligence is with all the modern technologies which we have is not to make a model, it's to make a useful model, so a model which is doing a good work. So that is the big difference from just calling a method and really doing something with it. And the conclusion is that we need at some point of time to convert data to stationary. This is performed by a procedure called differencing, which is taking a difference between consecutive observations that are called lags. Here is an example. Imagine the series is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and differencing is making a just dividing 1 from 2, 2 from 3, and this is the differencing which we receive. The purpose is to remove any trends and seasonal structures. A thing to note here is that some time series forecasting methods do not require stationarity like ARIMA, because it is because of this I here in the ARIMA. We're going to talk after a couple of slides what each of these letters means from the abbreviation. But the preliminary differencing is performed in ARIMA, but in another type of model like ARMA, it isn't. So you have it. It is a thing which is happening behind the scenes, but it's happening, and it is an important part to remove the time-dependent attributes like trend and seasonality. The time series analysis. From this section and on, we're going to talk about the correlation in data. So in the time series analysis, what is it? We are breaking the time series into multiple components. So if we start with the raw time series, which we have, it could be decomposed in this basically 4 types of components. The first one is a trend, which is some kind of a long-term tendency, like the cars on the market are getting more and more expensive because there is a significant shortage of chips, and electronics could not be produced, which is delaying production of new cars. So there is a crisis, and the prices are going higher. This is a long-term trend. Seasonality are some rhythmic forces like imagine during the holidays no one is buying a car, but around New Year people are getting fresh money or have a remaining budget, and they're usually buying new cars. With the cyclic, this is a thing which is repeating over a long period of time, and random noise are some irregular observations that cannot be predicted. This noise is a thing which is preventing us from making a good model. So if we're having too much noise, most likely we're too much random noise, so most likely we're going to have trouble having precise predictions. There is a few different ways to reconstruct the additive model, the final model, from these components, from the trend, from the seasonality, cyclic, and random noise. It could be additive model, like summing it up, or it could be multiplicative, or it could be some kind of a mixed model with multiplying using some coefficients like trend plus seasonality multiplied to cyclic multiplied to random noise. It's there is different approaches. This advanced slide is mostly to explain the correlation in data. Time series tend to have significant autocorrelation. This autocorrelation allows us to predict the future if we have autocorrelation detected for the past values. So the correlation is showing the relationships, and it's based on logged version of the time series itself. Like t, if t is now, t minus k is the previous value, 2 values before, 10 values before, or if the values are aggregated every 10 days, or sorry, aggregated every day, 10 values before is the value from 10 days ago. The meaning is that if you have a value which is close to plus or minus 1, it's perfect correlation. If it is minus, it's called that it's negative correlation, like one variable is getting up, but the other is going down just in reverse. But if it is close to 0, it means that there is basically no correlation. The way to measure this correlation is by using methods that already exist out there for you. You just need to know they exist, and for example, apply the there are some Excel plugins with which you could do that, but you could also use Python, of course. Me myself, I dislike R a lot, and when we're making an interview, asking someone about his machine learning experience, just asking about whether he's using Python on R is giving us impression whether he has gained his experience in academic or he has been a developer. To some extent, for some reason, R is quite challenging for people with developer background. While people coming from academia world are more comfortable with R. That's our observations at least. So with the Pearson correlation, you could evaluate the correlation, and you could create the so-called correlogram, which is to plot the autocorrelation function over different lags. And if the autocorrelation is low on any lag, it means that data are to large extent random. If we identify autocorrelation trend, this means that data are stationary. You could use the so-called augmented Dickey-Fuller test by applying this ADF Fuller function from Python. It's having a null hypothesis. Let us first explain what is a null hypothesis. You have probably encountered the fact that some of our socks are quite often missing from the washing machine, not from the laundry, sorry. And there is a null hypothesis saying that aliens are not to blame, and there is some other explanation for disappearing. And the alternative hypothesis is extraterrestrial beings have been transported themselves into our house in order to steal my socks. So the null hypothesis here is that the ADF p-value is less than 5%, so less than 0.05. And if you reject the hypothesis, it means that the time series is stationary. The zero hypothesis with the ADF is that the time series has a unit root and is non-stationary. Unit root is a little bit difficult term to explain, but it means that there is a random walk or stochastic trend in the time series. When we do common data preparation steps for time series forecasting and time series values, first of all, the interesting thing is, do we have missing values? Because some of the arguments don't work well if you have nulls, like you didn't have network connectivity and you didn't collect any data from some point or location. We start by parsing data from various sources, handling time zone information, for example. It could be UTC, and of course it's important. If data are collected in UTC and you want to predict something in local time, you need to know that, or you could have some date time offset. So all these things need to be taken into account. If there is missing data, There is you could later on come to this decision-making chart what to do. But if data are missing at random, you could the question is whether you could remove them, or if data are following some simple distribution, how you could impute data and replace. If it is a large temporary order data set, we could probably replace data with preceding values. So it's different decisions how to impute data when you have missing data. The next thing is frequencies and resampling. If you have irregular time series, like not every hour, not every minute, but you have some measurements after 2 minutes, then after 5 minutes, then after 10 minutes, then after 7 minutes, it's again challenging because the meaning of this time series is not the same. So you have to make the irregular time series regular. Then it's good to use something to help you here. It's an off topic, but we're using time series databases that are quite helpful in these aggregations. Yeah, you could hardly do that with SQL, for example. The next thing is the outliers. Outliers are extreme values that need to be identified and handled. There is a somewhat standard way of working with the outliers. If you have a distribution, this is the chart of a normal distribution. 50% of the data are between the 25th percentile until the 75th percentile. This is these are Qs. Q1, Q2, Q2, Q3, Q4. So 50% of data are here. So this Q1 and Q3 at the 25th and 75th percentile, you get where actually the difference between the values of the number at ending Q3 and the other at beginning of Q1, you make a difference, and this is your interquartile range, and multiply it to 1.5 is giving you the boundaries of what is considered to be normal. And you could think that everything outside of that could be could be considered as an outlier. So imagine you're predicting something and there is extremely high or extremely low value. You'd better remove them because they're going to damage your model more than to contribute. Now we're just in the middle, just a little before the middle of the time of our session. We're starting with the forecasting algorithms, so that after having this introduction in theory, you could make an appreciation of how these genius algorithms were made simple for you as user, and from that step on you could use them and make something even simpler for your end users or customers. The baseline of all that is the so-called naive algorithms. The naive algorithms could be considered as benchmarks, so it's good to compare. Imagine it could be just a kind of a straight line, and it's not good if your model is worse than the straight line. The naive model is to forecast the horizon based on the last value. So if I know that my last measurement was, let us say, 50 beats per minute, the naive model is saying that my next prediction is 50 beats per minute. I'm not trying to go and look anything in the past. I'm just reusing the last value. The so-called seasonal naive is an extension, and it is using a seasonal component and forecasting the matches based on the last t, which t is the size of a time window, t amount of timestamps. So we take, for example, the last day and repeat the whole last last day, and it is a seasonal naive model. A good one is you could think of it when we want to predict the hot water usage of a household. Imagine we take the usage from the same time yesterday, the value from the previous hour, and the same time last week. Apply certain amount of coefficients, and voila, you have very simple prediction for the next. But you're, of course, you're having assumption. And we talked about these assumptions, that the data are stationary, which means there is a trend which you could observe from the data looking back. Now we're talking about the autoregressive integrated moving average. This is what stands behind the abbreviation of RIMA model. This model was invented around the 90s as an attempt to describe the changes on the time series. So you see, 1970s. So it's about 50 years old approach, which is still working to a large extent well. So we're trying to describe the changes on time series with some mathematical approach, and it assumes that the future will resemble the past. We have been talking about that lately. And it's quite inaccurate when there is an unseen event, like there is a crisis, something happens. We have a model that is predicting the prices of cars, and we expect a drop around New Year because lots of people are changing their cars. But voila, in the COVID crisis, we have a shortage of machine chips, and nothing about that is confirmed, because you could just not go to the shop and buy a new car. You have to wait for 6 months, 10 months, like that. So people are not changing their cars at New Year, and the prices of the second-hand cars is much higher. With the moving average, it's a linear combination of the past forecast errors, and it impacts the random short-term fluctuations over a specific amount of time. If you remember the example with the voltages that change quite frequently, but when you aggregate, when you're not looking at the values every 2 seconds, but aggregate at every 10 seconds or every 1 minute, then you have something more steady, which is really much better predictable. The simple moving average is arithmetic mean of the previous 5 values or 10 values or 20 values. If we have values every 2 seconds and we want to aggregate every 10 to have one value every 10 seconds, it basically means aggregating the last 5 values, of course. And the integrated part, which makes the difference between ARMA and RIMA, is differencing to make time series stationary. The RIMA is having 3 key parameters, P, D, and Q. P is number of observations, and it is used to indicate the past. The D is the degree of differencing. So if you make differencing, we explained differencing a couple of slides ago, that it is the difference between the time series and a lagged copy of the time series itself. The degree of differencing is a number, and Q is the size of the window to calculate forecast, and it's about quality. So the quality process, the forecast is not affected by the previous sales, for example, but rather the errors in the previous forecasts, like that. And below you see how it is, how RIMA is constructed back from the results. So RIMA depends on some constant, the weighted sum of the last p values, which is the p parameter, weighted sum of the last q errors, the q parameter, after differencing of certain order, making differencing once is order 1. The seasonal RIMA is the next thing. So the seasonal RIMA is an improvement, extension of the RIMA, and it explicitly supports univariate time series data with a seasonal component, while that doesn't work well with RIMA. So a seasonal RIMA model uses differencing at a lag equal to the number of the seasons to remove additional seasonal effects. So you have a couple of actually 4 additional parameters, capital P, capital D, and capital Q, which are applied to the seasonal components. But the parameter space is going to become larger, and the ARIMA, if you want to do it to somehow tune the arguments by yourself and experiment, you have really a lot of combinations to try if you want to do it by yourself. Here is where AutoArima comes. Its basis of AutoArima, it's quite fresh. Its basis appeared in 2008 by, I have it written somewhere here, Hindman Kandakar. It is a research, I think it's a ResearchGate article. I had a look on it, but I didn't look through it carefully. So the basis of it lies on that effort. It tries to identify the optimal parameters of PD and Q, and as you could see here, it has 42 other optional arguments, which is a lot. If you, which means a lot of reading and wondering what is it all about and how it works. So it is a good illustration of how complex thing could become less complex, but still pretty complex. And the fit function is what is doing the magic. In Python, it mimics the R auto ARIMA, and one of the key things is that it looks Bayesian information criterion and archaic information criterion, so-called AIC, to pick the best model, because it is internally changing the arguments and trying to compare the model to pick the best model. So the criterion looks like something n, where n is number of observations multiplied to natural logarithm of sum of the square errors divided to n, plus 2k, where k is estimated number of model parameters, and the smaller the better, which means the smaller the criterion number, the better the model. So it's going to be picked by AutoArima. It's conducting differencing tests behind the scenes for you. However, you could by yourself check the order of differencing which you need by inspecting autocorrelation plots, doing this by yourself, or a way to do it, you could have the values in Excel, then shift the values a bit, or calculate the next column like something minus a cell minus the value in the next cell, and plot afterwards to see what is the result and whether you will see a trend or it's still going to look noisy. The pros of using this approach is, of course, it saves time. It's one of the simplest techniques for time series forecasting, and it eliminates the in-depth knowledge required. So let us say suitable for developers without too much data science background or knowledge. And of course, it reduces the amount of the likelihood of having human errors leading to bad predictions. The next model, the next type of models to mention is the singular spectrum analysis, SSA, which you could find in MLNet as implementation. SSA performs spectral analysis on the input time series, where each component in the spectrum corresponds to a trend, seasonal, or a noise component. So it's basically making a decomposition, and after this making a reconstruction after removing the noise. That is the two complementary stages of SSA. The pros of this approach is it's also quite flexible. Works with arbitrary approaches, and of course we would like our approach to be somewhat universal and to work in most cases as possible. It makes no assumptions to the data, like whether data are stationary or not. And the parameters in MLNet are train size, which is the amount of rows or train samples from the beginning of the data set which we're using. Series length are the series which we're having in the buffer to predict on. Like you could have data for 300 days, but you predict only on the last 7 days. This is the thing which we're using because yeah, because if we want to do all the analysis manually, imagine we observe the data, observe the seasonality, make the charts, make these conclusions, decide by ourselves. This is going to be device by device in one of the cases which we have. But these are IoT devices which are provisioned in homes, in cabins. Cabins are mountain cabins that are usually used in during holidays, not every holiday, and the usage is quite different. So the conclusions after investigating certain time series, the conclusions which you make are not applicable to the next. So we needed something to work on itself or automatically. So we're making a full grid of testing the series length, window size, and horizon, and calculating root mean squared error for a prediction. And this way, for every location, we're picking the best possible arguments that are giving us the best model. So the series length is the series in the buffer, like we mentioned 7 days ago. The window size is the length of the window on the series, the seasonality. This seasonality could be every 1 day something is happening almost the same way. And the horizon is the values to forecast. We want to forecast like 24 hours ahead. This is usually fixed from the from the task. The business requirement says that we need to do that and know this 1 year ahead or 1 day ahead. So with the parameters, there are no universal rules for parameter selection, and if you want to experiment it, is literally Cartesian product, and you may need to brute force. How does it look like? In MLNet, everything is a context. So you create a context, you load from file. Then create SSA pipeline with parameters, and make the training calling the single method fit. Then probably you need to make this evaluation, which I mentioned in our case is calculate the root mean squared error. And when you're ready to make your prediction, you just load the trained model and make the prediction. There is an interesting concept here called the checkpoint. The checkpoint makes it convenient for you to provide actual data for only most recent observations when you have all previous data. This avoids you having to provide all the data every time you want to predict. Then you want to use then you may want to use a checkpoint. But it is important to have in mind that the checkpoint may lead to creating a drift, and yes, you have to evaluate against all using last observations from the last month or last year if you have more data. So some things at the end are about experimentation. Regression model is another interesting thing. As far as I can see my time here, we have roughly 15 minutes. So I guess we'll be able to at least go through the demo of Facebook Profit. There is some important things to share about it there. So with a regression model, there is something different. With the time series forecasting, we don't apply any external knowledge. We just have time and value. With the regression, we want to predict a single numeric value, and it is using time series forecasting is using regression under the hood. It's like crawling and predicting with regression the next value, then using that value and predicts the next value, then using that value and predicting the next value until we reach the prediction horizon. So you apply regression multiple times. But when you so there is no problem in using a regression model to solve your task, and it's good to have in mind what features you could add. So starting from time and value, what we could add in addition to it. Now, the first thing is the date. You could decompose the date to year, month, day, and hour. When this is the first thing in generating new features, or it's called feature engineering. Feature extraction engineering is when, for example, from the date you are decomposing to year, month, and day. This is feature engineering. But feature extraction is if you just include GPS coordinates in your regression model. This is not going to disclose a lot of information to your model. So the point here is if you could make an extraction and calculate the distance to some key point, like distance to the center of the city, distance to the capital, or distance to the main office of a firm. The other types of features you could use are lags. What has happened in T-1, T-2, these are different lags you could add as features. Delta, what is the difference from the value in some time ago? If it is in hours, probably it's important to have T-24. So the lag is if on the single line, if the lag is in this way, in a single line on the data set, you disclose some historical information, and the delta is the change. How did it change over time? You could also use moving average to make things smoother. You could use sums as additional features. Don't worry, even if you add additional features, the feature engineering, not the feature engineering, the model would put additional different weights to this. You could also add features to that are based on domain knowledge. This could be coming from weather, GPS coordinates as mentioned. It could be reference price of fuel, for example, reference price of the gasoline or diesel. So this is also another valid approach to make time series forecasting. Azure ML service, we're going to mention it. It's quite handy if you go and use it. Our demo is not going to be about it because at least we have had a couple of sessions in the past with Azure AutoML, but it's probably the most powerful and still very easy way to do machine learning. You'd have to upload the file, then select a task which you're solving. In our case, in our presentation, we're creating time series forecasting model. Then you have a interactive way to set parameters, and you could have you could receive metrics at the end, like the root mean square there of based on prediction is 22. Which depends on the values which we have. 22 could be large or small, depending what is our mean value. Like if we produce values like 2000, 3000, 22 is small, but if the values are 2, 3, 5, etc., then 22 is a lot. And AutoML is having Python SDK, and you could use in Azure ML service, there is the so-called ML Studio, which is interactive drag and drop environment, and not to be mistaken with the ML Studio Classic, which is going to retire in 2024. We're closing to the end of the presentation. 2 more slides remaining here. The next one is Facebook Profit. So it's created by Facebook, or call it Meta if you wish, in 2017. So it's quite fresh. It's a procedure for forecasting time series data based on additive model. It trains quickly. It's highly accurate. It isn't having requirements for background like statistical background like it is with AutoRima, and it's tens of parameters. Can be used for a multivariate time series analysis. So just to remind, multivariate is when you're not using just the previous value, but you could add some additional variables. It handles outliers well, and also is immune to missing data, which is also it's saving a lot of effort to you. And it could work well with multiple seasons, and also use some specific special information for special events like holidays, etc. With the AutoML service, there is something interesting here in the parameters. You could specify the country or region for holidays, which we're trying to, the model will try to exclude the information about the holidays and handle holiday information in different way than the rest of the data. So being able to handle holidays, especially when that is automatic, is really beneficial. And under the hood, it's working with a Python package Profit, and additive models look like that: trend, seasonality plus holiday plus error. So the trend changes over a long period of time. Seasonality is the periodic short term changes. Holidays is the effect of holidays on the forecast. Obviously, people are traveling more on holidays. And it's even implemented in Azure in the Custo language. And of course, error is some unconditional errors that are difficult to predict. The last slide with content is how to set up Profit. It's really not straightforward. I personally spent 16 or 18 hours setting it up, and now I can set it up in less than half an hour. There are lots of things it didn't want to work on my computer, on my Python environment. Then I decided, okay, let me start with Azure Data Science VM, because you probably know this is a VM you could create quite quickly in Azure. It has everything you would need for data science. You would need to know that, first of all, it's expensive, but a good balance is creating a VM on a 4-core hardware. Then I found the 3.8 kernel in the Jupyter Lab, and activated the kernel and started installing the packages in it. Anything didn't work from the environment itself or from the Python itself, because some of the packages require compilation. And Conda, as a package manager, is having its own C++ compiler. So we could, in the activated kernel, we install PyStan, which is the key dependency of Profit, and then the Facebook Profit. By the way, I also tried creating a virtual environment based on Python. I think in my case it was 3.7, but after a lot of effort, I didn't manage to create it. I ended up wiping the whole virtual machine. Probably some of you are asking themselves the question, and how it compares to all of that. There is a good article from 2021, which is basically last year, sometime last year, less than a half year ago even. There is an article which you could go and find available in PDF. It's even not an article, it's ResearchGate. And it's comparing profit and deep learning to ARIMA in forecasting wholesale food prices. And ARIMA performed really well, and profit didn't perform that well. The root mean square there is the smaller the number, the better. And these are also two neural network approaches for that are sometimes better, sometimes worse. So ARIMA, although it is quite old, it's still gold, we could say. Okay, around less than 5 minutes remaining until the end of the session, but this is my data science VM. This is the way my data look like. You see, I created my environment some time ago, and I haven't activated my Excel, but at least these are the values and the values and the time for which the values apply. So this is my data set, which I'm going to load here. These are the Python packages we include. So after loading, head is on the data frame is giving you the top 20 with if you put the parameter. I think the by default value is 5. So this is the data set we have, data frame we have loaded. The profit itself works with the columns ds for the time and y for the value. Y comes from y axis, and this is the description of the data. You could see information about maximum value, mean value, what is the count of values which we count of rows which we have. I forgot to mention that intentionally we're having some missing data, some zeros, some quite high values as well. Okay, the next thing is to after changing the columns, describe once again. Then we're creating a model with 95% confidence, and saying that we have daily seasonality, to expect totally weekly seasonality and yearly seasonality, and make the model fit. Then we use want to predict the future, the next 36, which is a day and a half points at, and we say that the frequency is hour. Make our forecast, and because we have these values at the end, we select to see what we have in the data, what new we have as values. This is the forecast. After the forecast, we have some additional columns in the forecast frame. So the most, if I just skip that part, show you the rest of the columns. Here we select just a couple of them, but we could show all. You have trend lower, trend upper. These are lower and upper boundary of the for that value, and there are lots of other columns to the right. Yeah, so we just focused on a couple of them. We make we plot the result. Then we could perform a cross validation. While it is running, you see at the back the the progress, and then show the performance metrics based on these cross validations. So there is a root mean squared error for each of the points. You see, it's, I would say, quite high. This is in liters, and our values around our values are really this is way off, I would say, like 40-50 as an error. So here we make cross validation and show the metric, which is in percentage. No, it's not in percent. Sorry, I have selected root mean squared error. So the root mean squared error plotted over the horizon is like that. So you could see this the information above here in comparison. So we have quite bad predictions for the next 5 to 10 hours, but afterwards is better. We could decompose and you see how the prophet has decomposed the series, and you could also play with parameter grid and playing with like changing prior scale and seasonality prior scale. These are parameters which we play and experiment with. Over the initial is starting at 5,000 hours. The period is 36 hours, which means every 36 hours we're predicting for the next 36 hours until the end, which is the total data size is 5,600. So if we start initial 0 hours, we're going to have a lot of iterations here, really. Well, here we have about 600 divided to 36 amount of iterations, which is relatively 16 forecasts to calculate the root mean squared error, and at the end to see root mean squared error based on the argument. So this could help you pick better parameters for that. That was all for today. Hope I will be able to get into more depth in a separate session afterwards on one of the next events and get into more details if you're interested in. So thank you for your attention and thank you for joining. Keep tuned to our next events. Bye.
Thank you and have a great day.
Hello.
Hello?
Hello.
Hello? We can hear you.
Yeah.
We
Can
can
you?
hear you.
Yeah. Yeah. Okay. Good.
You can share your presentation and start.
Yeah. Okay. So yeah, I think I have already shared my screen. So hopefully you still seeing my screen, and you also see my browser as well. So this is my browser. Mm. Can you see my browser?
Yes, everything is fine.
Oh, okay. Okay. Thank you so much. So shall I start now, or we are waiting?
No, you can start directly.
Okay.
So have a great presentation.
Yeah. Okay. Thank you. So I'm just starting it now. Hi all, thank you and welcome to my session, Machine Learning using Azure Machine Learning Studio. Purpose of this session is to provide you a very quick overview of Azure Machine Learning Studio and show you how you can use this in your domain problem without writing a code or without knowing the language like Scala, Python, Java, or without data science or maths knowledge. So stay tuned with me. Let's start with myself. I am Alpa Budbati and I'm working as Azure consultant at Cluster Reply. I have provided you my LinkedIn information. So in a case you would like to join me or if you have a question later on, then please feel free to ask me in a LinkedIn. I am also Microsoft certified trainer and I have a certification in sorry, in Azure Data Engineer, Azure Data Science and Azure Developer. So let's move into today's agenda. Today's agenda is divided into two main parts. In first part, I'm going to provide you a quick overview of Azure Machine Learning. It's like what is machine learning, what is Azure Machine Learning, key terms of a machine learning, and a basic steps which we need to follow in a machine learning solution. And then I will show you a quick Azure Machine Learning Designer tour in a Azure portal. And in second part, I'm going to show you 3 demos. So in first demo, we're going to see a classification model to predict a loan approval. Like this user will get loan or not. We can get idea based on that demo. Then we're going to test that demo using the Postman. And then we are consuming it that model using the other Azure service such as Azure Data Factory. And you can use same thing in Azure Power BI or Power Desktop as well. And this session is for introductory session and it's a no code or low code session. So that's why it's for everyone who have a basic knowledge of maths or data science or machine learning or programming language or not. This session is for everyone. So let's start with machine learning. What is a machine learning? So machine learning is a computer program or system that can learn from experience. And this experience comes from data or examples. So we definitely say that data are a main backbone in a machine learning system. You need a huge amount of data so a computer or system can learn by themselves and they find a pattern in that data and they try to predict for a future that this person will get loan or not, there can be a failure happen or not, or anything like they're recommending you. Those all things they do because of a data. They have a data. So it finds a pattern and it predicts for a future. And this they will do without being told them, without explicitly writing a code. This is purely computers understand from data and their examples, and they learn and they save as a experience, and based on their experience, they find patterns. So this is the basic machine learning definition. And in our daily life, we are using the machine learning, and we even don't know. We are using machine learning from starting from wake up alarm from Alexa or Google Home, or we are using when we turn on our TV and Netflix suggesting few items. That's because of the recommendation system, and behind that recommendation system, machine learning is used. Even we do anything in YouTube or LinkedIn or any social media websites, behind the scene they are using the machine learning algorithms. So this is a basic things about machine learning. So let's see what next. So like, what is a machine learning? Azure machine learning. So Azure machine learning is a machine learning on a Azure cloud. So we can say that it's a machine learning service, which is a cloud based service for creating, managing your machine learning solution. You can use Azure machine learning to create your machine learning project or solution. You can use it for data analytics as well. You can do a data analyze also using the Azure machine learning. You can cleansing your data. You do so many things using the Azure machine learning in a either a portal, or you do using the code base. So let's start with why we need Azure machine learning. As we said earlier, today data generates exponentially, huge amount of data. So if we do that by manually, it's very time consuming. So that's why we need a machine learning, and because Azure provides very good benefits, so it's very good if you use Azure machine learning or machine learning on a cloud rather than in our local machine. So let's start with first benefit. It is a PaaS service. That means you don't need to worry about computer infrastructure, hardware, software installation, or web server configuration. This all will done by Azure. You only need to focus to create your model. And because of that reason, you can very quickly and efficiently build your machine learning solution within a few days uh, once you have a data clears. Also, it's a no code or low code or code first. It allows you to create your machine learning using drag and drop modules. Or if you are very good in a Python or Java, then you can create your model using the code. Also, it provides a built-in algorithms. So for example, it provides image classification algorithm, which if you have image ready, then it will easily, you can use that machine learning model and you can classify easily that is a apple or orange, is cat or dog. Very easily you can do it without spending time on creating your own model. It's speed up your data science process because you can spin up your compute by just a few click away. You don't need to order your hardware and wait for delivery and then you set up and install some software for that hardware. This is all done by just a few button click away in a few minutes job. You can spin up your GPU very quickly, and you can scale down or scale in automatically if you don't need it. So it saves money as well. And last but not least is a deployment. Deployment is very easy using the Azure machine learning. You can do it by few click button away using the Azure portal, using the Azure machine learning studio, or if you use a coding like code first, then also few lines of code which help you to deploy your Azure machine learning model. So these are the main benefit of using the Azure machine learning service. Now let's move into key terms of the machine learning. These are the very basic key terms which we use in a machine learning system. There are so many, but for a beginner, this is enough if they understand. So let's start with first one, which is a features. Features, if we compare this with any data or any query language, for example, SQL data language, then you will familiar with a table. So table have a columns. So features we can compare with columns. Features is like independent columns which help you to predict your output, which use for calculation for your output. So in my database, you can see that this is a very simple database. This is for supervised machine learning, and it has a only 5 observation or row. This is very simple data set, but in real life you don't have that one. You have millions of data, and you have millions of not millions, but you have at least 200 300 columns or features. So in our example, you can see that these three like house size, location, and age are features. They directly related to my target value. So these are the features, or you can say independent variable, or you can say it independent parameters, which directly affect the output. So these are the features. And let's move into next one, which is a target. Target is nothing but it's a output. Target is what we're going to achieve. So in our case, we are going to achieve that what would be the house price for that location, for a particular size, and for particular house age, like how old house is. So based on these two parameters, we will predict the house price, and that is our target. So in our situation cases, target is a output and which is a price. Next one is a training data. So you can see that these are my simple data, and I have a 5 observation or a rows. So now I need to split my data into two different data sets, training data sets and testing data sets. So training data sets is used to do train your model. It help to model, so your model will be trained on your training data, and then it can use for a calculation for a testing data. So that is your training data, which is nothing but your data set divided into two separate parts. Maybe it's 50-50, or maybe it's 70-30, or whichever way you prefer based on your domain problem. So that is my training data in this scenario. And this is my test data, which used to test my model. So these are the very basic key terms of a machine learning system. Now let's move into steps to create a machine learning model. So this is the first step, which is a data processing. So what happened in our domain problem when we try to find out the machine learning solution? Before that, we need to know what is actual issue, what problem we're going to solve. So for that, we need to decide first of all our problems, and then we need to find out data. And this data, in originally it won't be in a proper shape. It comes from different source system, it comes from different places, so they are not in a proper format. They may be structured data, unstructured data, or semi-structured data, and huge amount of data. It may be useful data, and some of them are not useful as well. So once we get all data, we collect your data, then we need to cleanse them. We need to remove the missing value if there are a missing value, and those fields are very important. Then we need to remove a duplicates value, and we need to apply a few kind of transformation or conversation. For example, we have a field which is married or not. So it's like yes or no. So it's always have a two value in your old data set. So we can convert them into numerical value 1 0 or 1. So this way, machine learning system work very fast if we you convert them into numerical value. If it's a limited data set, then we can convert it in a numerical value 1 0, or maybe 1 2 3 4 5 if it's only 5 value throughout your data set for that column. So that way you convert them, you can categorize them, and you can convert them into numerical value. So once we have those kind of thing is done, so that means now my data is okay in a proper format. So next step is to feature selection. So here what we will do, because not all of my features input fields are directly related to output. So that's why I have to remove unnecessary fields or columns there, because it cause a performance issue. So in feature selection, we are selecting a particular important fields or features or input variable or independent variable or input parameter which directly related to my problem solution, directly related to my output. So here we are selecting so for example, earlier we have 230 features, but now after feature selection, I have only 100 features. So that is a feature selection. So by this two step, now my data is in a proper format. It's a proper format and it's a meaningful data. So now it's time to split my data into two different formats, test data and training data. And you can split, again I said you earlier, you can do it 50-50, you can do 70-30 or percentage, or you can do according to what kind of your problem, because it depends on problems what we have. So that is a split data. And once we split our data, then we need to use a train model. So train model, we use our split data's training data, and you use a train model. So it's use two parameters, train model and train data, and it train your model. So once it's trained your model, then we need to score our model to see how good our model. So for that we passing now this time we passing our testing data and a model, and based on that it will evaluate, it will score our model, how good our score, like it will predict outputs, and then we evaluate it model, which give you overall how our model good is. It provides how much accuracy, is it 100% accurate, or it's only 80% accurate or 99% accurate. So here we have, it provide the performance matrix as well. So these are the basic 6 steps. And generally when we solve any machine learning model, then we will repeat this step again and again and again until we get accurate results. Accuracy is what we expected. Then we deploy our model. So these are the basic steps in a machine learning model. Now let's move into quick tour of Azure machine learning. So for that, let's go to Azure portal here. So let's go to here first of all. So this is a portal.azure.com. If you are new, then you can register it. It's a free. You will get initially first month, it's a free credits. And or if you have a Visual Studio subscription, then as a part of that you will get 115 pounds or something like that credit, which you can use for learning Azure Machine Learning Studio. So here, for example, in portal.azure.com, you search a machine learning. So we are going to create a machine learning workspace. So we first create a machine learning workspace. So here we can select a user group. So I'm selecting the same user group which I have, but you can create new as well. And then you can provide a suitable name for your machine learning. This green marks mean its name is available. So it should be unique as well. So sometimes if you don't find it, then you need to add either few numbers or maybe you need to rename properly. So that's available only and only for you. And then you select a location. Then um, you will see that these are the other things as well. So this is my namespace name, which is a ML demo alpha. I have selected location. So these are the storage account, keyword, and application insight. So when you create your workspace, it will create three other things, which is a storage account, keyword, and application insights. And you can rename as well here. If you like to proper name, then you can create a new name as well. But I'm just keeping as it is. So these storage account used to store your machine learning model. Key vaults help you to provide the security. It stored the secrets for your model. And application insights help you to find out if there is any issue, then you can see a log in application insight. So these are the three important things which created along with your workspace when you're going to create your workspace. So let's click here. So now this is my first machine learning workspace. Let's create it. It will take some time. So while it's creating it, I will show you what I have already available. So once you create your machine learning workspace and you go to your workspace, you will see these kind of things. And here you can launch your studio, or you can click this URL to launch your studio. So these two way you can launch your studio as well. So let's start with a launch here. So this is my machine learning workspace, which I already created earlier. And our one is still going to create in here. It takes some time. So meanwhile, I'll just show you how it looks. So this is your first landing page. And here you can see that you can create, let's start with here. So if you are familiar with a Python or programming language, or you like to learn those things using the programming language, then you can start your machine learning solution using the notebook, where you need to write down a code in a Python language. And this is automated ML. So for example, you would like to know very quickly that which model is best for your data. Then you can start with the automated ML. So here you will provide the input parameters, your data, and you provide threshold, like which output parameters, what kind of the s- things you expecting. So you will giving accuracy and few other parameters along with your data, and machine learning automatically run algorithms in parallelly, and it will define a best model based on a given data and threshold. And then that model you can select it, and then you can modify it as well, or you can use as it is, and you can deploy your code. And it is a very quick. You can do it because you don't need to worry about it all. Azure AutoML will find out for you everything, best model, and it create model for you, everything it do it. So you just need to deploy it later on. So that is AutoML. And in today's session, we're going to see a designer, which is a drag and drop, no code or low code. So it's for everyone. It's like anyone who don't have any basic knowledge about maths or data science or machine learning, they still can create their model using the designer. So let's see what happened here. This one. So yeah, so this is my workspace, and it's created, and you can see that it created my workspace along with three different objects, which is a key vault, application insight, and a storage account. So you need to go to resource, and this is your landing page now for your workspace, which you created, and you can launch it here. And this is your first workspace, and here you can see that the same thing which I showed you earlier available. So here you can see that these we already have seen data sets. So data sets is you can create your own data sets here, and these are the 5 main assets. So for example, let's create a data set. So you can create your data set in various different method. You can create it from local file, you can create it from data store, you can create it from web files, and you can use a open data source. So let's start creating data set from your my local machine. So I need to give a suitable name, and then I need to define is a tabular or file, and then I can give a description, but I'm keeping as a simple at the moment. And here you can see that it by default it store this store, but you can create your own data store as well. And then here you will upload your file. So I'm uploading file from my local machine, which is here. So I'm uploading the data here, and it has a CS loan up related data, and it's in a CSV file. You can skip validation, or you can do validation as well. Then you just click next, and it will parse your data sets for file, and it prepare for you a proper formats. Okay, let's skip it, which I think I did it. Okay, skip validation, and then we need to do. So now you can see that it's I can set this parameter. For example, my CSV file have a different CSV file having different formats like encoding formats or comma separated or something like that. If you don't have a header or something that, then you can edit here. If you skip few rows as well, if you like, and that's it. And then I do click next. So this way it will create my data set. My data set will be registered here. So this is my first data set which I have just created. So I have now my data set in a Azure cloud. Earlier it was in my local machine. So now let's click here. And here you can see many things. You can consume your data set. You can see these are the code which you can use even in Python as well. And you can explore your data. So here you can see that what data you have in your data set. You will see the number of rows and you can profile it. You can profile it very easily and it give you results like what you need to do, like how many records are missing. It give you statistic as well. And you can unregister your data set if you really don't need it. But if you need, then you can keep it. So I have just unregistered it. So this way you will create your data set and your data set will be appear in your pipeline when you create your pipeline. So now let's start with pipeline. So what is a pipeline in Azure Machine Learning? Pipeline is nothing but it is a sequential step which help you to create your machine learning solution. You can score it, you can train your model, you can score it, you can evaluate it, and you can deploy it. So the all kind of things allow in a pipeline. Even you can just data analyze using the pipeline. So pipeline is a basic unit in Azure Machine Learning which we create our flow which have all steps available. So that is a pipelines. Once you have a pipeline and when you run your pipeline or submit your pipeline, it generates experiments. So experiments is like we have experiment in our life. For example, we doing cooking experiments. So we cook today something, so it's one experiment for us, and then tomorrow we'll improve it and we do another we doing the same thing again, then it's another experiment. So in same way in here also, every time when we submit or run your pipeline, it generate experiments and it's save under the experiments in here. At the moment I don't have anything, but you will it appear here. So those are experiments. Now let's model. So once you deploy or publish your model, it appears here. And when you deploy your inference pipeline, it generate endpoints, real-time endpoints, which you can see it in here. Even in batch endpoints also you can see it here. And so those are the things, and these endpoints you can use in any other application, like for example other Azure services, for example Power BI, or you can use it for Azure Data Factory, or you can create your own web application or window application and you can call that one, that endpoint, that machine learning model, and it's so your application passing the input parameters and your model will return the results. So those you can do it using the consuming this endpoints. So these are the basic 5 data assets in Azure Machine Learning. And let's move into manage. So here you can see compute. So as I said you earlier, it's a PaaS service, so you don't need to worry about compute. But to do a calculation, we need a compute. So for that, we need to choose a compute from here. There are 4 kind of compute, and you can very quickly you create your compute. So let's create one compute from here. So like this way, you will select your priorities. You select types, which kind of the problem you have. Based on that you need a types. If you have huge amount of image or video, or you are doing to predict something based on as a data, then you need to use GPU. Otherwise, if it's less data, you can use a CPU. You can select size as well, and here you can see that they have already configured here, and it's a how much cost as well, you can see that. Based on that you can select it. So for my problem, it's just a demo. So I can choose this basic one. And then I can give a suitable name. And I can select a number of node as well. So I'm keeping as it is, but this varies based on what kind of the problem we have. If it's using some parallel processing, it huge amount data or calculation, then we can add a node as well here. And we can say idle time is 30 seconds. So after that, it will automatically off. So let's create. So this way I'm creating my computes. As I said earlier, it's few button click away. So this way you don't need to worry about that. You can configure GPU, CPU or any other configuration as well. So it take few minutes. So we don't need to worry about this now. So this way you can create your compute here, few button clicks away. And they are from different purposes as well. So let's see now next one, which is the environment. So these are the environments, but here we are not doing anything. So we don't need to worry at all. But when we create compute, it will generate one entry here, which is provide us machine learning environments, like which Python it install, TensorFlow version or anything like that, or even a GPU configuration. So those all things will appear automatically here when we create a compute data store. So when you want to store your data, which is, for example, Azure SQL Server or Azure Synapse Analytics or Data Lake Gen 2, then you need to create your data store here. And you can see that these are the main data source available. You can use Azure Blob Storage, File Shared, Data Lake Gen 1, Data Lake Gen 2, Azure SQL Database, Postgres SQL database, and Azure MySQL database. So these are the data source at the moment supporting. So you can create your data store faster. It's like a connection manager which hold the connection sync for your data source, and then you can create your data sets. So that way you can create your data store, and you can store a result of machine learning into your SQL Server or a Data Lake Gen 2. So for that you can create a data store and then you create a data set. Labeling. So if you have a huge amount of data and you would like to labeling it, then you can use these techniques. You can create label projects and link service. You can create other Azure service, link service here as well, like Azure Synapse Analytics. You can easily do it here by just clicking here. So it will integrate your Azure machine learning with other other Azure service. So these are the basic things in Azure machine learning. So now let's go to home. Let's go to home and create a new okay, let's close this one now. Let's close even this one. Okay, so let's okay, the one more thing is here is like inbuilt already available pipeline is there. So you just need to click, like I did click, this is already available model as well. I just need to select a compute, that's it. So how good it is, you can see that it's already have everything here. So I don't need to worry about it all. I can change my data set, I can select few columns, that's it. So I can use that as well, and that one is available in here. These are the already, you can see more sample as well. So these are the old samples. So if you would like to learn about them, then you just need to select those sample and you need to create your compute, that's it. And then you can run it, you can analyze it, and you can get more ideas as well. So now let's go to home again and let's create now new pipeline. Okay, so here we are going to create our pipeline. And if you remember, when I registered my data set earlier, you will see that it appears in here in data sets. So that is my data set. But you can see these are the sample data set which is already available when you create your workspace, which is a 16 different data sets. And you can see more other things as well. You can have a you do transformation, you can do machine learning. Algorithms available is 19 algorithm is there, train model is there. There are different languages, well, text analytics, computer vision, recommendation, anomaly detection. So those kind of algorithm is already available. As I said, you built-in algorithms, built-in models, so it's available here. So you don't need to worry at all about that. You can just drag and drop. So let's start with drag and drop. So this is my data set, and I'm just to drag and drop my data set, and that's it. Let's close this. So see, this is my data set, and if I visualize it, I can preview my data. And so this is my data set. So you can see that it say number of column is 12 and number of row is 614. So this is observation, and you can see profile as well on that. So here what you will do, you will find out that which column is missing. See here, missing value is that. Even also you can see it's mean, max and count, number of row, as well as you will see missing value. See, those all kind of things you will get it in here, even in percentile as well. Okay, so we focus on missing value. So if we see missing value, so here is missing, these are all missing value which is in here. Here is a 32 times is missing. Let's see what it is. So it's a self-employed. Okay, that's fine. Let's scroll down little bit. Here 22. So that one is a loan amount. If your loan amount is missing in your history data, then that's not a good data, because when you create your model, it not get a clear picture, and it predict wrong things, because as we said, machine learning model is heavily depend your data. So your data as much as possible is accurate data. History data should be accurate as much as is possible. So for that, we need to remove this missing data. So let's go to here, and we now add missing data, or we can use a select as well. First of all, we select data. So we selecting few columns in my data set. So this way I added another node or module, and this is a very important thing. I have to connect them. I just need to drag and drop. So now they are connected, and now I can select data. Like I have a 12 columns, but which one is important? So I'm just removing by name or by rule. So I'm just adding all 12, or I can remove all 12 as well. I can add individual as well. So I'm just adding all 12 and then removing few of them. So for example, this one I don't need. I don't need co-applicant homes. For example, this 2 column I don't need it. So I just remove it and I save it. And that's it. So here if I going to see data visualization, you will see that it has limited 10 columns only. Okay, and then now we are adding the missing data. Everything is available here, you just need to search it. So now we going to see a missing data. Let's close first, because this is an important thing. This red sign means you need to do something is not correct. So first step is to you connect your two components, where your output of one component is the input of another component. And here now I need to define a rule that which column I would like to apply a missing data. So I selecting all of them, but you don't need to all of them. You select only which is important. So I think earlier we have removed this one, and we removed income as well, which is this one. So yeah, I am defining here that these are my columns, and I would like to apply missing rules. So if anything is missing in this column, I need to apply these things. So what is here? So here you can select a cleansing mode. You can use a custom cleansing mode. You can replace with mean. So for example, your input columns have a numerical value, then you can replace with mean as well, or you can use with median as well, or mode. But if it's a string or something like that, then what you will do, you will remove your entire column, or you maybe remove column. Remove column is not a good option, so I will say remove the entire row. So that is my basic rule. Here you can apply the lot of other filter as well, but for beginner this is enough. So let's close this one. So this one. So now if I visualize my data, you will see that it has now a limited results. Let's save it. So it has now limited results, and now let's add so for example, data is ready. Now we can apply a split. We can split our data now. So we can split our data in a train and test, but before that we need to join them. So we are splitting our data, and here the data is in two different sets. Okay, and then now we can add here model. This model also available, so we can use any model, like we can choose any. See, these all models available. There are so many other, but we can just select anything. Like for example, we selecting this model. So this is my model, and I just need to add train model as well. This is a train model which have two inputs. First input is split data, and another input is a model. And now here this line means something is missing, so I need to train target or label column. So that is my which is my label column. Is my label column is um, loan status, that this person will get loan or not. So that's it. So this way I will train my model, and then I can add a score model. This way it will score my model, and it will give me two additional columns for score my model. And like it's give a probability as well, and it's result as well, like it should be loan given or not, like that. And then evaluation okay, only good thing, let me edit again because I have accidentally deleted it. So it has a two input. It has the output of a train model, and it has our testing data as well. And now you can add here evaluation. So that's it. So this is my model is ready now. So I can submit it, and I can visualize data as well. At the moment I'm not going to visualize it, but you can do it like that way. You can visualize your data as well, but at the moment option is not coming, but I will show you in my pipeline. So this is a very easy way you can build your pipelines. And let's see, now I already have a pipeline, so I will show you all later on this. But this way you will create your pipeline, and you can rename your pipeline as well, suitable name. Yeah, and this, when you submit it, by default if this one you don't submit it, then it auto save. So this is your pipeline draft, and you can submit your pipeline draft, and or you can publish your pipeline draft. So once you submit your pipeline draft, it will appears in your experiments. Let's submit it, but it will complain about compute because we haven't selected compute as well. This is a compute. Let's see if we have any compute available. Then we can select it. Yeah, compute is not available at the moment, so okay. Yeah, I think it's still creating compute which we have earlier stopped. So that's fine. So this way you will select your compute after creation of your compute, and then it will allow you to do extra things. You can visualize things and you can submit your pipelines, or you can publish your pipeline, and then it appears under the experiments. So let's discard this because I really don't need it. So let's go to here. So when you submit it, it appears in here in your run history. So okay, so let's now go back to, let's close this one as well because we don't need it. And now let go back to our slide. So this is the very quick tour of Azure Machine Learning Studio. Now let's move into very important thing and very basic thing as well when we create our machine learning pipeline. So we going to see this process in a diagrams. So let's start with first. So when you create your pipeline in a Azure Machine Learning, your pipeline which is in a draft state. When you submit your pipeline, done. It generate a pipeline run under the experiment, and you can do it so as many time as you want unless you satisfied. Also, you can publish your draft pipeline as I showed you earlier. So when you publish your draft pipeline, it generate a pipeline endpoints, and it's called a published pipeline published. It will see there your endpoints, and you also can submit your pipeline endpoints as well. So this cycle you will do it again and again and again, and once you're happy with the results, you can deploy it using the creating a inference pipeline. And there are two kind of inference pipeline: batch inference pipeline and real time inference pipeline. So batch inference pipeline, you can publish it, and then it will generate a pipeline endpoints which can be consumed as well by other applications. And in real time inference pipeline, you need to deploy it. So when you click on deploy, it generate a real time endpoint, and that can be consumed by other application as well. And if you are not happy with after some time, then you need to submit it again. You can submit your publish pipeline in batch in inference a batch pipeline inference pipeline, and you can do some experiment, do some changes, and it generate a experiment. It appears into a pipeline run. So these are the very basic information. When you create your pipeline, then you will get idea what happened when you submit your draft pipeline, or what happened when you submit your inference pipeline, where you can see the history. So these are the information. Let me go to portal and I will show you if I have submitted anything. So this is my experiment, and at the moment it look like they are showing all experiments under here. But generally I think they have recently changed something. Otherwise there are the three different categories: pipeline run, um, I think, which is here, yeah, publish pipeline, pipeline run. Those are two things will be available there, but I think it's recently little bit changed. So now let's go back to here. Mm. You will get more information in this link if you like to know more about. And now let's move into uh, demo, which is a loan approval using the Azure Machine Learning Designer. So for that, I have already created pipelines. So I have a train pipeline. So let's go to train pipeline. So this is my train pipeline. I have already created it because it takes some time when you create your compute, or when you submit your pipeline, or when you publish your pipeline or deploy your pipeline. It will take 5 to 10 minutes, or sometimes it's more as well. So I have already created it. So here you can see that this is my data, and here I will show you, you can visualize as well. So this is my data. I can preview my data here, and you can see that I have a number of observation 614, which is very less. In real time it millions of rows, and I have only a 12 columns, and this is all my data. Okay, and you can here you can apply some statistics as well. So these are ready-made, already applied. It give you mean, max, count, missing records. So you can see that these are the all missing things, and which we going to remove this missing rows. Okay, so let's close this one. And so here we are selecting the columns. So you can see that we are selecting only limited columns. Here you can see that. So now I have only 9 columns. I have removed the 3 columns from my data set because those columns are not directly related to my domain problem or outputs, and it's not helping, it's unnecessary there, so I have removed them. And then now I'm cleansing here missing. So I'm applying cleansing data set, and I'm saying that remove the all missing columns having missing value. So you can see that now my observation is only 490, which was earlier 614, and columns as it is. So now if I select, if anything is, for example, loan amount, where is loan? Yeah, if it's missing, then here you can see that missing value is 0. Now all columns have a data. I have removed the missing information, remove that row itself. So now my data is ready. Now I'm splitting my data into 2 different data sets. So you can see that now data set 1 and data set 2. So here you can see that after splitting, because I have used a 70 and 30. So now I in 70% data is 340 observation. And here for testing data set, you will see that it has only the less amount of observation, which is 143, which is a 30% of my original data set. So now you can see that I'm passing my training data here. I'm selecting this algorithm and I'm train my model. Okay, and then this will give me a result, like how accurate my model is, what is giving, is it predicting correctly or not. So for that you can see that it's generated, earlier it was 9 columns, but 9 now I have 11, and you can see that it's generating the labels, scored label, and it generates a probability as well. So you can say most of them are accurate. It look like accurate, but you can see this one they predicted wrong, second entry. It's supposed to be true based on history data because history has given them, but here scored is false. It's predicted wrong. So my model is not as much accurate as it should be. It should be accurate 100%, but it look like it's accurate less than that. So that way you can evaluate see a score, and here it will give you matrix evolution model, how accurate my model it is, some matrix as well. But we don't need to worry about at all for this matrix for a beginner. So you can see these are the matrix. This is ROC curve, precision recall curve, and you can see here more information as well, confuse matrix, and we only interested in accuracy. So at the moment accuracy is 78%. So it's good, but it's not good as it should be. So I can again change it, I can do some extra things, and I can try again and again. I can change something, apply transformation, apply some rules, and I can publish my model again. So this way you can do it again and again, and that's in my train pipeline. So now if once I'm happy with my train pipeline, I need to generate an inference pipeline. So this is my inference pipeline. You can see that. And now inference pipeline do not need a split data or other things because it's missing data or anything, because inference pipeline is used the result of my train model and is used the data, new data. So that's it. So this is very very simple, and here you don't need to do anything. Once you click on the inference pipeline, it will generate few models extra, and it's remove the model extra, and it will generate like this way. So this is my inference pipeline, and once I deploy my inference pipeline, it generate an endpoint which is here. So this is my pipeline endpoints now, and it's my real-time pipelines inference pipeline. And if you see here, you can test your pipeline as well here, endpoints, and you can click button. So you can see that it passed the value. You can copy it in a JSON as well. So this is my data, sample data, and I can consume it in a different way as well. I can consume it using the different programming language like C Sharp, Python, and R. I can do this as well. Sample code is already ready-made, so I don't need to worry about it all. I can just use that in my C Sharp or Python or R project, and I can consume my model, Azure machine learning model. And so for example here, so if I want to consume it via Postman, then what I need to do? So that is my next demo, which is this. So for that, let's go back to Postman. So this is a Postman which help to do your testing, especially for REST API or API related testing. So here you can see that it wants a URL. So this method. So method is a post method because we're passing the information and we're waiting for result, and we need a URL. So this URL is my score URL, which I get it from where? I get it from here. So that is this REST endpoint, this one. So you can copy that one and you can paste into your Postman here. Okay, so that is a one thing. Next thing is you need to add a header. So for that, you will select your content type is application JSON, and then you need to authorize that. So for authorization, you will add here beer space, and then you will add a key, and that is this key. So you copy this key, primary key, and that one you need to paste after beers space, and then you paste here. That's it. So you set your authorization setting, you set a content type, and now a time to pass a body. So this one also you can directly copy from here if you are new to JSON, and if you don't know or you don't want to spend much time on that, then you can directly copy this sample data like control A, control C, and you can paste it here. So this way you can taste it, but then you will can generate your more data as well. You can use this structure, you modify this data again and again, and you can apply here more than many data here to taste your performance related testing as well. So at the moment I have passed only three data set, three observation, 1, 2, and 3. And so now when I click on send button, it will generate a 200 and okay, and it generate a result as well. You can see that it's generate same thing which we saw there. We will see here loan status, loan score label, which generated by my machine learning model, and accuracy like probability as well. Okay, so this way it will return a result that this person will get loan or not. So this way you can call your model in a Azure, in a Postman as well. You can test your model. And now let's move into last demo, which is testing your model using the Azure Data Factory. You can use here Power BI as well, but I have used Azure Data Factory, or you can create your own application as well, and then you can consume as well. So this is my Azure Data Factory, and here you can see that I have added a web activity. I can use here machine learning activity as well by just drag and drop, and then I can pass required parameter like URL, method, and body like that. I can select I means first I need to create link service for Azure machine learning, but then after I can use even pipeline ID or pipeline endpoints, and I can give a few parameters here, and this way I can call my machine learning in a here as well, but I have used via web activity. So even Azure Data Factory also drag and drop. You can easily do it, no code or low code. You just drag and drop, and you can connect as well like that way. It's like SSIS. If you have used earlier SSIS, then it's very similar to that, but it's in advanced, and this is in a cloud and advanced as well. So I have used a web activity, and you can see that I have passed URL. This is same URL which I have used in Postman, which is a score URL. I selected method. I passed these two parameters, which is a content time and authorization, and I pass the same method body. Or you can change your data as well here. That's it. Once you do that, then it will run it and it will show result here. Okay, so let's see here. So this is my model. So this is model returning me this result. Okay, and its results now pass or store. You can store into Azure other data store, like you can pass into database, Azure SQL database, or on-premise database, or like that, or blob storage, or data lake Gen 2. And here you can see the information as well. So this is the read output from my machine learning model. It's predicting it that it will get loan or not, but you can do many things here. So this is a demo with Azure Data Factory. Now let's go back to here and see what left. So now we need to summarize our session. So earlier we have seen Azure Machine Learning, which is a platform as a service and very powerful service which help you to create your machine learning model. You can score it, you can evaluate it, you can deploy it using the Azure Machine Learning service, as well as you can analyze your data. You can use simple SQL query or Python query or R query there, and you can analyze it. You can see it. You can analyze it. You can add more information like that. You can do those things in Azure Machine Learning Studio, Azure Machine Learning service. And then we have seen a key terms of the machine learning, which is a features, target, training data, and testing data. Then we have seen a machine learning model creation basic step, like collection, data collection, then feature selection. Then we seen split data. Then we seen a score model, evaluation model, and deployment. Then we seen a quick tour of Azure Machine Learning, which is drag and drop interface. You can join one output of one node or component to input of another node and component, and you can very quickly build your pipelines here. And then we have seen a demo for loan approval. And then we tested that using the Postman. And then we have consumed that model using the Azure Data Factory, which you can do it in different component as well, different service as well. And I just would like to let you know that there are two events, upcoming events is coming. If you're interested, then please register that. And with that, I would like to thank you for a sponsor, Microsoft. And I would like to thank Global AI community in Bulgaria, because without their help, this event won't be possible. And now I'm open with any question. Yeah. Is there any question? Hello.
Alpha.
Yeah, hi.
I don't see a question.
Yeah.
Thank you.
Thank you so much. Thank you.
Have
Bye.
a nice day.
You too. Bye.
Thank you.
Microsoft from California. 大家好，我是卢建辉，用户的版面王子。Hi, I'm Jennifer Marsman from the United States. Hi, I'm Akata Gupta from India.
Hi, I'm Andrew Renton from the USA. I'm Joe Spizak from Maryland. Hi, Nabil Eddie Daoud from Ghana.
Hi, I'm Monica Levin.
Merhaba, ben Türkiye, ben Darun Yönden.
Hi.
Не можах да пусна видеото. Сега ще го опитам отново. А? Не бе, един съм. Сигурно за това не успях.
Hey, my name's Apansha Malik and I'm from Melbourne.
Excellent Somi, it's Val here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
I'm Prasant from California.
大家好，我是卢建辉 Netherlands.
I'm Alpha Cassie from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Arpita Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joe Spizak from California.
Hi, Midi Edi Daoud, Greece, Africana.
Hi, I'm Ana Famana.
Merhaba, ben Türkiye'den Daron Yönden.
Hi there. Hi. 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 Hi.
Hey, my name's Apansha Malik and I'm from Melbourne.
Excellent Somi, it's Val here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
I'm Prasant from California.
大家好，我是卢建辉 Netherlands.
I'm Alpha Cassie from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Arpita Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joe Spizak from California.
Hi, Midi Edi Daoud, Greece, Africana.
Hi, I'm Ana Famana.
Merhaba, ben Türkiye'den Daron Yönden.
Hi there. Hi. 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 Hi.
Hey, my name's Apansha Malik and I'm from Melbourne.
Excellent Somi, it's Val here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
I'm Prasant from California.
大家好，我是卢建辉 Netherlands.
I'm Alpha Cassie from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Arpita Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joe Spizak from California.
Hi, Midi Edi Daoud, Greece, Africana.
Hi, I'm Ana Famana.
Merhaba, ben Türkiye'den Daron Yönden.
Hi there. Hi. 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 Hi.
Hey, my name's Apansha Malik and I'm from Melbourne.
Excellent Somi, it's Val here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
I'm Prasant from California.
大家好，我是卢建辉 Netherlands.
I'm Alpha Cassie from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Arpita Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joe Spizak from California.
Hi, Midi Edi Daoud, Greece, Africana.
Hi, I'm Ana Famana.
Merhaba, ben Türkiye'den Daron Yönden.
Hi there. Hi. 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 Hi.
Hey, my name's Apansha Malik and I'm from Melbourne.
Excellent Somi, it's Val here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
I'm Prasant from California.
大家好，我是卢建辉 Netherlands.
I'm Alpha Cassie from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Arpita Gupta from India.
Hi, I'm Matthew Renton from the USA.
USA. I'm Joe Spizak from California.
Hi, meeting Eddie Daoud, Miss Africana.
Hi, I'm Anna from Anna.
Merhaba, ben Türkiye'den Daron Gönder.
Hi. Hi. Hi.
Hey, my name is Malik, and I'm from Melbourne.
Exit some here.
Hi, I'm Alan.
Hi, I'm Amy.
Near the test. They come from Spain.
Hi, I'm Agatha from India.
I'm Matthew Renton from the USA.
I'm Joe Spizak from California.
Hi, meeting Eddie Daoud, Miss Africana.
Hi, I'm Anna from Anna.
Merhaba, ben Türkiye'den Daron Gönder.
Hi.
Hey, my name's I'm from Melbourne.
Exit Sami with Val here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Near the test. They come from Spain.
I'm Prasant from California.
大家好，我是卢建辉，英文版 Nederlands。
I'm Ralph Gassi from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Agatha from India.
Hi, I'm Matthew Renton from the USA.
I'm Joe Spizak from California.
Hi, meeting Eddie Daoud, Miss Africana.
Hi, I'm Anna from Anna.
Merhaba, ben Türkiye'den Daron Gönder.
Hi.
Hey, my name's Malik, and I'm from Melbourne.
Exit Sami with Val here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Near the test. They come from Spain.
I'm Prasant from California.
大家好，我是卢建辉，英文版 Nederlands。
I'm Ralph Gassi from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Agatha from India.
Hi, I'm Matthew Renton from the USA.
I'm Joe Spizak from California.
Hi, meeting Eddie Daoud, Miss Africana.
Hi, I'm Anna from Anna.
Merhaba, ben Türkiye'den Daron Gönder.
Hey, my name's Malik, and I'm from Melbourne.
Exit Sami with Val here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Near the test. They come from Spain.
I'm Prasant from California.
大家好，我是卢建辉，英文版 Nederlands。
Ralph Gassi from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Agatha from India.
Hi, I'm Matthew Renton from the USA.
I'm Joe Spizak from California.
Hi, meeting Eddie Daoud, Miss Africana.
Hi, I'm Anna from Anna.
Merhaba, ben Türkiye'den Daron Gönder.
Hey, my name's Malik, and I'm from Melbourne.
Exit Sami with Val here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Near the test. They come from Spain.
I'm Prasant from California.
大家好，我是卢建辉，英文版 Nederlands。
I'm Ralph Gassi from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Agatha from India.
Hi, I'm Matthew Renton from the USA.
I'm Joe Spizak from California.
Hi, meeting Eddie Daoud, Miss Africana.
Hi, I'm Anna from Anna.
Merhaba, ben Türkiye'den Daron Gönder.
Hey, my name's Malik, and I'm from Melbourne.
Exit Sami with Val here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Near the test. They come from Spain.
I'm Prasant from California.
大家好，我是卢建辉，英文版 Nederlands。
I'm Ralph Gassi from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Agatha from India.
Hi, I'm Matthew Renton from the USA.
I'm Joe Spizak from California.
Hi, meeting Eddie Daoud, Miss Africana.
Hi, I'm Anna from Anna.
Merhaba, ben Türkiye'den Daron Gönder.
Hey, my name's Malik, and I'm from Melbourne.
Exit Sami with Val here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Near the test. They come from Spain.
I'm Prasant from California.
大家好，我是卢建辉，英文版 Nederlands。
I'm Ralph Gassi from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Agatha from India.
Hi, I'm Matthew Renton from the USA.
I'm Joe Spizak from California.
Hi, meeting Eddie Daoud, Miss Africana.
Hi, I'm Anna from Anna.
Merhaba, ben Türkiye'den Daron Gönder.
Hi there.
Hi.
Hi. Hi.
Hi.
Hi.
Hey, my name's Akansha Malik, and I'm from Melbourne.
Excellent, Sami. It's Bal here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Welkom van Spanje.
I'm Prasad from California.
大家好，我是卢建辉，英文版 Nederlands。
I'm Rafa Gassi from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Akata Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joseph Isaac.
Hi, Midi Eddie Daoud, Greece, Africana.
Hi, I'm Ana from Anna.
Merhaba, ben Türkiye'den Daron Yönden.
Hi there.
Hi.
Hi.
Hey, my name's Akansha Malik, and I'm from Melbourne.
Excellent, Sami. It's Bal here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Welkom van Spanje.
I'm Prasad from California.
大家好，我是卢建辉，英文版 Nederlands。
I'm Rafa Gassi from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Akata Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joseph Isaac.
Hi, Midi Eddie Daoud, Greece, Africana.
Hi, I'm Ana from Anna.
Merhaba, ben Türkiye'den Daron Yönden.
Hi there.
Hi.
Hey, my name's Akansha Malik, and I'm from Melbourne.
Excellent, Sami. It's Bal here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Welkom van Spanje.
I'm Prasad from
大
California.
家好，我是卢建辉，英文版 Nederlands。
I'm Rafa Gassi from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Akata Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joseph Isaac.
Hi, Midi Eddie Daoud, Greece, Africana.
Hi, I'm Ana from Anna.
Merhaba, ben Türkiye'den Daron Yönden.
Hi there.
Hi.
Hey, my name's Akansha Malik, and I'm from Melbourne.
Excellent, Sami. It's Bal here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Welkom van Spanje.
I'm Prasad from California.
大家好，我是卢建辉，英文版 Nederlands。
I'm Rafa Gassi from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Akata Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joseph Isaac.
Hi, Midi Eddie Daoud, Greece, Africana.
Hi, I'm Ana from Anna.
Merhaba, ben Türkiye'den Daron Yönden.
Hi there.
Hi.
Hey, my name's Akansha Malik, and I'm from Melbourne.
Excellent, Sami. It's Bal here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Welkom van Spanje.
I'm Prasad from California.
大家好，我是卢建辉，英文版 Nederlands。
I'm Rafa Gassi from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Akata Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joseph Isaac.
Hi, Midi Eddie Daoud, Greece, Africana.
Hi, I'm Ana from Anna.
Merhaba, ben Türkiye'den Daron Yönden.
Hi there.
Luis Beltran. Luis Beltran. Luis Beltran.
Hey, my name's Akansha Malik, and I'm from Melbourne.
Exit Sammy in België.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Je hebt de tekst. Welkom van Spanje.
I'm Prasant from California.
大家好，我是卢建辉，英文版 Nederlands。
I'm Fagasi from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Arpita Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joe Spizak from California.
Hi, benim Eddie Daoud, biz Afrikaner.
Hi, I'm Arif Manan.
Merhaba, ben Türkiye'den Daron Yönden.
Hi.
Hi.
Hey, my name's Akansha Malik, and I'm from Melbourne.
Exit Sammy in België.
Hi, I'm Alan Smith.
I'm Amy.
Je hebt de tekst. Welkom van Spanje.
I'm Prasant from California.
大家好，我是卢建辉，英文版 Nederlands。
I'm Fagasi from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Arpita Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joe Spizak from California.
Hi, benim Eddie Daoud, biz Afrikaner.
Hi, I'm Arif Manan.
Merhaba, ben Türkiye'den Daron Yönden.
Hi.
Hey, my name's Akansha Malik, and I'm from Melbourne.
Exit Sammy in België.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Je hebt de tekst. Welkom van Spanje.
I'm Prasant from California.
大家好，我是卢建辉，英文版 Nederlands。
I'm Fagasi from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Arpita Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joe Spizak from California.
Hi, benim Eddie Daoud, biz Afrikaner.
Hi, I'm Arif Manan.
Merhaba, ben Türkiye'den Daron Yönden.
Hi.
Hey, my name's Akansha Malik, and I'm from Melbourne.
Exit Sammy in België.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Je hebt de tekst. Welkom van Spanje.
I'm Prasant from California.
大家好，我是卢建辉，英文版 Nederlands。
I'm Fagasi from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Arpita Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joe Spizak from California.
Hi, benim Eddie Daoud, biz Afrikaner.
Hi, I'm Arif Manan.
Merhaba, ben Türkiye'den Daron Yönden.
Hi.
Hey, my name's Akansha Malik, and I'm from Melbourne.
Exit Sammy in België.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Je hebt de tekst. Welkom van Spanje.
I'm Prasant from California.
大家好，我是卢建辉，英文版 Nederlands。
I'm Fagasi from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Arpita Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joe Spizak from California.
Hi, benim Eddie Daoud, biz Afrikaner.
Hi, I'm Arif Manan.
Merhaba, ben Türkiye'den Daron Yönden.
Hi.
Okay, so good afternoon, everyone. Thank you for attending this presentation. Before we get started, I hope that you are enjoying the event, the Global AI Bootcamp in Sofia, Bulgaria. Well, I wish I could be there. Okay, just a second. Can you?
Luis?
Yes. Hello.
I don't see your comment, your screen.
Okay.
Come have screen is shared, but
yes, you
not
cannot
picture.
see me. Okay, let me check because I turned on the video. Can you hear me? Hello, can you hear me? Can you hear me? Hello. Ah, yes, perfect. And my screen, can you see it? Because I just share it. Okay. Can you hear me? No, not yet. What can I do? Because well, I just have the options to edit my name and change avatar. I can see my camera here. Okay. Yeah, there is a message from someone. They say they can hear me. On YouTube, they can hear me. No image. Okay. Yeah, that's weird. Let's see. Let's try another browser. Okay, no worries. Hello? Okay, I can see. Yes, I think it worked now. Perfect. Okay, thank you very much. So I just want to confirm that you can hear me. Yes? Could you please confirm? Okay, perfect. It says I can start. Okay, perfect. Excellent. Thank you. So, welcome to this presentation, Voice Biometry Recognizing Speakers in Our Applications. My name is Luis. I am from Mexico, although currently I am living in Czech Republic. And today I'm going to explain about this topic. You know, the human voice has a unique characteristics that can be associated with an individual, a specific person. So the speaker recognition service can recognize speakers, can identify or verify by comparing these unique voice characteristics with registered or pre-registered voiced signatures. Okay, so thank you to the sponsors that make it possible, this event. And well, just not to take too much time. Well, yeah, I am a Microsoft MVP in artificial intelligence in developer technologies. Here you have my contact details. You can follow me on Twitter in case that you have any questions or later you would like to discuss anything about this presentation. Feel free to reach out. Okay, so let's get started. Yes. Just a second. And you still see my screen? Okay, yes, perfect. I see it now, but okay. I think you cannot see the screen now, right? Or only my camera. Okay. Okay. So, yeah, this is our agenda. We are going to talk about cognitive services and speaker recognition. There are several topics among there. So, probably you have heard about cognitive services. They are APIs, SDKs, and services available that aim developers to create smart applications without the use of direct artificial intelligence and without the need for data science skills and knowledge. Azure Cognitive Services enable developers to easily add cognitive capabilities into their applications. So our software, our apps can see, hear, speak, understand, and even begin to reason with the users. The Azure Cognitive Services portfolio can be divided into 4 main pillars: vision, speech, language, and decision. We are not going to explore all of them. We are just going to focus on speech. Very briefly, this is a set of services that allow to convert speech to text and text to natural sounding speech. Natural sounding speech. But there is also a fourth capability, which is the speech translation, which allows you to perform real-time speech translation between languages. And we have our main service, which is the speaker recognition. Speaker recognition can help you determine who is speaking in some audio message. Speaker recognition capabilities are provided through two APIs: verification and identification of the speaker by the unique voice characteristics using voice biometry. You, as the developer, provide audio training data for a single speaker. This creates an enrollment profile or signature based on the unique characteristics of the speaker's voice. Later, you can cross-check audio voice samples, new audio messages, against that profile to verify that the speaker is or isn't the same person. This process is known as speaker verification. So we want to know if this audio aligns with some other profile. Yes or no. Right. Or we can cross-check the audio voice samples against a group of enrolled speaker profiles to see if it matches any profile in the group. This process is known as speaker identification. Okay, so that's two APIs, two activities. In short, the difference between identification and verification is: identification is the process of detecting which member from a group of speakers is talking. Verification is the act of confirming that a speaker matches a known or enrolled voice. Typically, in identification, you return a person, someone. In verification, you say this person exists, or sorry, this audio exists in some profile or no. So let's see these two processes in detail. You see the example, right? Speaker identification, whose voice is this? Speaker verification, is this voice, yes or no? Okay, but it's important to know these processes. So let's talk about speaker verification. Speaker verification compares the voice characteristics of an individual's speech with some registered or enrolled voice signature of some identity. For example, you can use it for customer identity verification in a call center or some facility access. How does it work? Speaker verification can be of two types: text dependent or text independent. Let's see the first one. Text dependent verification means that speakers need to choose the same passphrase to use during both enrollment and verification phases. Text independent verification requires a longer voice sample that must start with a particular activation phrase for enrollment. But this person can speak whatever they want, including during the recognition phase. So what does it mean? In text-dependent verification, the voice of the speaker is enrolled by saying some specific text, which is known as a passphrase. phrase. There is a set of predefined phrases. Actually, we are going to mention. Oh, right. Well, yeah, we can say that there are several pass phrases. You can think of them as passwords. Okay. So the speaker picks one, speaks, says something, some of these, right? And the system, the API extracts voice features from this audio message in order to create a unique voice signature. At the same time, this chosen password or passphrase is also recognized. Together, the voice signature and the passphrase will be used to verify the speaker later. So, in the verification phase, the ID associated with some individual is sent to the API. The service extracts voice features of this new message and the passphrase from the input speech recording. Then it compares these voice features and the passphrase against the enrollment profile of the corresponding speaker. The response will be accept or reject. And the API will also return a score that goes from 0 to 1. 1 means that, or closer to 1 means that the new message, which includes a voice and some audio, some text, matches or is closely similar to a profile and a passphrase that is registered. And a low score, closer to 0, means the opposite, of course. Yeah, basically that. And what about text independent? In text independent verification, there are no restrictions on what the speaker says. It can be any message during enrollment. But there should be some, let's say, some initial activation phrase in order to enable the enrollment. There are no restrictions on the audio sample to be verified. That's why it is called text independent. And the analysis is based only on the voice features to score the similarity. Beware, the APIs are not intended to determine if the audio is from a live person or a recording of an enrolled speaker. So, yeah, later we are going to mention this is known as speaker spoofing, because, for example, right now I am talking, right? But maybe I could have pre-recorded this speech, right? And just move my lips, and the recording is talking, right? And you will not notice the difference. So it's like a playback from the singers, right? When they are performing in concert. So yeah, the service is not able to detect that. As we mentioned, actually, well, in the current version of the text-dependent speaker verification API, there are these 10 English phrases for the speakers to choose from. You can create your own passphrases by sending separate requests to the text-independent speaker verification API and speech-to-text API. Combining a speaker verification result and speech recognition result, you can determine the speaker's identity. And well, actually, this is one recommendation: generating random phrases for the speaker to read is effective to prevent some replay attack. Because, well, these text-dependent passphrase are very well known. If we go to Microsoft documentation, we will find them. So, yeah, it facilitates or it speeds up the text-dependent strategy. But on the other side, maybe someone records our voice by saying any of this, and it bypasses the check. Speaker identification, on the other hand, is used to determine an unknown speaker's identity within a group of enrolled speakers. Speaker identification enables you to attribute a speech to individual people, persons, speakers, and get value from scenarios from multiple speakers. For example, support solutions for remote meeting productivity to identify who is talking, who is speaking. How does it work? The enrollment for a speaker identification is text independent. So that means the speaker who will be registered in the API can say whatever they want. Then, similar to a speaker verification, the speaker's voice is recorded in the enrollment phase. The voice features are extracted to form a unique voice signature. Later, in the identification phase, the input voice sample is compared to a specific list of enrolled voices. The response includes an ID and the top 5 ranked IDs, which are kind of similar. There are also scores from 0 to 1. If none of the candidate speakers return a similarity score or of greater or equal to 0.5, the response returns a string of 0 with no match is found. So let's say some new user tries to log in, but this person has not enrolled before, right? So that's the idea. In this case, we will get a 0 or no match, right? But if these two people previously enrolled in the system, they can be identified, right? With the voice characteristics. So we have talked about data that is processed by speaker recognition. We have the enrollment audio. In this case, that's whatever the user is saying. With the enrollment audio and an identifier that is generated by the service, a voice signature is created. This voice signature is a numeric vector that represents the different characteristics of the speaker's voice. that were extracted from audio recordings. Then we have the passphrase signature, which is the phrase, the message, the ones that we mentioned earlier, right? We also have the recognition audio. After enrolling a speaker, there will be a new audio input along with some identifier. The voice signature will be processed to determine if the audio matches the enrolled speaker's voice signature. As a customer of this API or developer, you can manage and delete all the data that is associated with any individual, such as enrollment audio, enrolled voice signature, and passphrase signature, but no recognition audio. It is not possible to save this recording audio into the system. As we mentioned from the very beginning, audio allows you to identify, it's a biometric characteristic. So privacy or data privacy and security is important. Microsoft does not store any audio samples. They store a profile, they store a signature in a secure environment or system in Azure, in the cloud. But it's up to you when you want to remove the data, the container. The characteristics, the speech audio, is only used when the algorithm is upgraded, when new features are extracted by new requests. In this case, it means that you can trust the cloud provider, Microsoft, that your data is secure. Regarding this topic as well, there are some supported languages, such as English from US, Australia, Canada. There is French, German, Italian, Japanese, Chinese, Portuguese, and Spanish from Mexico or Spain. These are the supported languages. Another important element is that not all Azure regions allow speaker recognition. Only very specific ones, mainly from the US, such as Central US, East US, West US. There are some in Asia, and in Europe, North Europe, West Europe, and also United Kingdom South. You can create a resource in Azure, a speech service in any of these regions, and you will have this capability available. And you can also write a program, a software in any of these languages: C#, C++, Java, JavaScript. There are libraries, there are SDKs. And if your language is not supported, you always have the REST API. Okay, so let's go to the demo. And in this case, okay, just a second, I might need to connect to my other computer. And I will show some example. Just a second. Okay, yes, it is loading. Okay, I might need to go back. Just a second. To my local host /voice. Okay, yes. So in this case, I have already created an Azure resource. As you can see, it's a speech service, okay? So we create a speech service. It can be free or standard. Then we claim two things: the key, which I can copy to the clipboard, and I can paste it here. Sorry, not there. It's here in the key. And the endpoint, I can get this one from the overview. It is here. But this endpoint, it's only up to the COM, and that's it. Is US API Cognitive Microsoft COM. That's it. Now let's try it. We will explore the code in a minute. So there are several features here. Let's create an identification profile. And in this case, I am going to be presented with some text, okay? So just a second, because sometimes I lose my mouse. Okay, yes. Okay, so let's click on this first button. Oh, not sure why it failed. Wow. Interesting. Okay, let me try something else because I also have it in another folder. Just a second. You know, it happens, right? It was working before I restarted the computer, but I have a copy here. What is? A voice biometry. Okay, here. Let's copy and let's place it here. Okay, so I will try index. We have the key, we have the endpoint, and let's click go. Okay, wow. Okay, not sure what happened because it was working earlier. No, this is not. Okay. Okay, it seems that the verification phrases is working, but at least I will try this demo. I am not sure what happened, but okay, let's click here. So there are some passphrases. I mentioned this earlier, okay? So I'm going to choose one, for example, this one. I am going to create a verification profile. So I need to repeat 3 times this. So the system can create a profile based on the voice characteristics and also the passphrase. This passphrase is like a password, okay? So let's click here. And no, probably there is something with the microphone. Okay, I think I might know what is happening. Not sure if it's because I am joining from the desktop, because yeah, this is a remote computer. Okay, what else can I do? Because yeah, I don't have permissions from the microphone, probably. Okay, but I will check. Microphone. Okay, it's in Spanish. Okay, this was unexpected. What else we can do? Okay, I know what I can do. So just give me a second. I am going to do it from my own computer. I might need just to open the firewall, so and add some rule. So okay, just a second. You know, this happens. Okay, so this one. And then settings. Very quickly, let's add a port 80. Okay. Now I am going back here. And let's see. Okay. It might work. Let me just copy the endpoint and the key. Okay. So let's try again. Let's go to create identification profile. Okay. I think the issue is that I am using the microphone already for to talk in this presentation, and it is blocking me the access. I didn't expect this issue because it should ask me to access the microphone, or it should ask me, okay, do you want to use the microphone? But it is not giving me access. Okay, so I will try something different. I will do it. Well, this project is already created by this author. So I will try the direct demo. Okay, so let's do it. It should work here, but okay, here it is working. Okay, so never gonna give you up, never gonna let you down, never gonna run around and desert you, never gonna make you cry, never gonna say goodbye, never gonna tell a lie and hurt you. So this is just a test, and we are creating a profile. Okay, so as you can see, in this case, the software, sorry, the API, by using the API, I said something, I am the speaker, and there is a profile. There are some characteristics that were extracted. And this profile will be linked to someone. So I will say, okay, who was talking? Luis. And let's click OK. That's it. Enrollment is complete, as you can see. Now let's click on Identify. And let's talk about this. They are the world's most fearsome fighting team. They are heroes in a half shell, and they are green when the evil Shredder attacks. And, well, yeah, this is the result. As you can see, we are working with identification. And it says that there is a score based on what I said, right? The API returns 0.73 probability that it is Luis, which of course is me, right? So this is the identification, but how this was created? Okay, so if we check the code, we have the identification. Just a second. I need to move this a bit. Okay. Yes. And in this case, we have the enroll new profile, right? And we are enabling the microphone, right? And we are sending this message, okay? The create profile sends a request to the API, right? So there is the create identification profile endpoint. Just a second, right? So if we click here, you will see the URL, which is this one. This, of course, is the URL from Microsoft API or speaker recognition API. So we send a request with the audio, and it will return this profile, which is associated to a specific person, right? So that's the idea. There is create, there is enroll, right? Enroll is to actually register it into the secure system from the cloud, right? So you see the enroll process. It's another post request, and after that, we check if the enrollment is completed or not. That's the poll for enrollment method. In this case, it's a get request, as you can see here, right? To check if the enrollment has completed or no. At minimum, we need to provide 15 seconds of audio in order for Azure to create or to build this profile. If we submit less seconds, it is not possible. There is not enough data. Okay. And well, if the process is finished, yeah, we get enrolled, otherwise not done yet. And the final process would be to wait and to check if this person can be identified or not, right? If there will be a new message, right? And there is identify method, right? Identify profile endpoint, which is identification text independent, because it is a different message. If you check for enrollment, it was a different text. Actually, we can see it here. For enrollment, we set this paragraph, this song, actually. And for identification, it was a totally different message. So it is text independent in both phases. Azure is going to compare the profile to see if there is a match or no. And if there is a match, what's the probability, or how similar these profiles are, right? And that's what we get. I'm going to refresh this to see just the verification. For the list verification, as I said, I'm going to choose some well, let's pick the first one from the Godfather, right? And create a verification profile. I am going to make him an offer he cannot refuse. So as you can see, okay, I think I didn't say it good, so I will try again. I am going to make him an offer he cannot refuse. Okay, here it is. So it is recognized. This is the first one. I need to say it again. I am going to make him an offer he cannot refuse. Good. I have said it 2 times. And finally, once more. I am going to make him an offer he cannot refuse. Okay, so it is recognized. What does this mean? That now there is a signature. It's like similar process when you enroll a thumbprint, a fingerprint, right? You place your finger several times until a pattern is discovered. The same goes here. We use this same text, which is both a password and used for pattern. And now let's click on verify. This is text dependent. So that means that I have to say exactly that same message. And also me. Let's say this passphrase is associated to me or to my profile. Let's click on verify. My name is unknown to you. And yeah, this is a reject because I am not using the same passphrase. Probably the profile, the signature is similar. It's the same person, but I am using text dependent verify. So I need to know the passphrase. I'm going to say it now. I am going to make him an offer he cannot refuse. And as you can see now, the result is success, accept. Okay. Similarly, if we check verification text dependent, we will have the endpoints where we can send the audio. Basically, we are sending, right, this audio message. In this case, well, there is a recorder library, JavaScript library, which basically has everything to simplify the request. But as you can see, or it can be a bit obvious, in all cases, for when you send or submit data, there is a post request, right? And you send this context, sorry, this audio, this actually the file, as you can see, a blob file is created from the recording. I am going to share this website where you can actually test it, but you need this data in order to actually test it. So let's, I think I cannot share message here, but okay. So you can just get some screenshot from it, okay? So let's continue from our presentation. Well, there are some guidelines for this. First of all, well, of course, understand the capabilities, what speaker recognition can do and cannot do. Respect individuals' right to privacy. If you are going to implement this into your system, there must be consent from the user to this application, because you are using their voice, and their voice is important for for identification. If they don't want to participate in this, you don't have to force them. So you need to offer some other alternatives. You can talk to your customers. There should be some feedback so they can tell you what they think about this implementation. Also, you need to train them so they can know how to use this in case that they accept to use the voice. Here there are some examples, right? Multi-user device personalization. So, for example, depending on the person, some menus, some options will be presented. Also, call center customer verification to demonstrate maybe there is some bot on the other side, and you need to use your voice to verify that it is you. Also, some check-in of patient, of course. Once you talk, the system can tell, okay, it's John, it's Luis, and this is the prescription, or this is the background, the historical data, medical data. There are some limitations. All these messages all this audio must be sent as WAV files with mono aural 16 bits and kilohertz. At maximum, you can send up to 5 minutes of audio for enrollment. Sorry. The APIs don't store the identifiers. You need to save them on your own. When you send this, let's say, data, this audio, probably you saw that there were some IDs. Okay, probably, yeah, okay, I missed them, but there are some IDs you need to collect, right? If, let's say, there is a file, WAV file, with more than one people speaking, this API cannot recognize more than one person in one audio file. So, yeah, in your file, in your message, only one person can speak at once. Actually, in the whole audio, in the whole audio, it is not possible to identify, okay, in this moment, there is Luis, there is John. No, only one person. We also mentioned that the speaker recognition cannot differentiate between synthesized voice or a pre-recording. And something really important, in the latest version of speaker recognition, Microsoft limits the access. So in order to use speaker recognition, you need to submit a form because right now the access is a limit. So you need to provide why you want to use the service, because the idea is to prevent some, let's say, for example, deep fakes, misleading content, or harmful software. Even recording, let's say, audio of people without them noticing. So that's why this service needs to be, let's say, it's in limit access. Even though it is generally available, you still need to submit or fill in a form. Then speaker recognition will be activated for you. If you don't submit this form, all the requests will fail. And with that, I conclude my presentation. Please, if there is any question, I will do my best to try to answer them in the chat. Thank you for your time. And hopefully we will meet in another event. And well, if there are no questions, enjoy the rest of the Global AI Bootcamp, Sophia. And again, thank you very much for your time. So, goodbye.
Thank you very much, Luis. Thank you very much, Luis. Thank you very much, Luis. Thank you very much, Luis.
Hello, everyone. Okay, I'm so happy to be online in those troublesome times. I'm going to talk today about a rather complicated topic, which I hope will not be presented in a complex way. Okay, just confirmation. Can we all hear and see me? Okay. Dear friends, I can't see you, but I hope that you see me and you hear me. We'll try to talk today about the topic of healthcare and how do we tackle that with modern tools, specifically with artificial intelligence, and how do we overcome the challenges that appear through that. Just final confirmation, if we can see and hear. Okay, can you see my slide shared? Okay. Okay, 1 second. Give me 1 minute just to make sure I reconnect the slides. Okay, second, we have a little glitch, as it seems. Okay, 20 more seconds, please. We have a little technical interruption with my slide demonstration. Okay. Okay, guys, I think we're back online. Sorry for the interruption. So today I'm going to talk about the concept of healthcare and the application of artificial intelligence, data science, and data mining, and what are the new challenges there are of that, and what are the modern tools we tackle with, and specifically the role of Microsoft. It is the time to thank our sponsors. Well, thank you, Microsoft, for the opportunity, for the tools that you provide, and for the generous support through the years. For our organizers, and specific thanks to Mikhail Matev and Valentin and Stefka for taking care of those events for so many years. Today, my role will be to explain this concept of healthcare, although I'm not in the best health myself right now. Just a little bit about myself, those who don't know me. I'm a PhD in computer science. I've been dealing with multiple businesses, and I'm a serial investor into several things. And a lot of you know me through about talking about energy and more specifically digital twins. What we took through the years, we took our understanding of digital twins and what can be done with artificial intelligence, and we started to plug that into domains. And one of the domains I'm going to talk today is connected to one of our newest startups. It's called EPICS. It stands for epigenetical research. It's not listed in my bio because it's in the making, but this is basically the connecting to our dreams of connecting. We're finding a better way to use technology for something that has a bigger impact for the humankind. Today, those who don't know, the concepts, I'm going to repeat some of the basic concepts. What's epigenetics? Why we do that? What have we done so far? And I'll be joined later by my partners, Ivan and Matthew, who will provide a specific example of what we've been doing. My role today will be to explain the concept, explain why we do it, and try to connect the dots to what Microsoft has to offer, the latest in the developments of Microsoft tools, and let's take it from there. Just quickly, I'll repeat, this was part of my previous presentations. What is epigenetics, right? We all know what's genetics. Epigenetics basically was coined in the 40s. It's basically the study of the field of genetics and the different physiological and cellular phenotype variations that are caused by external or environmental factors that basically switch genes on and off and basically affect what happens to you if you have something encoded in your genes, whether it's good or bad. We're trying now to understand what is the influence of those external factors and why they, how that relates to specific expressions connected to diseases or the way you live. What is the interaction between individuals, genotypes, age, lifestyle factors such as like diet, alcohol consumption, different environmental factors can basically affect why something is happening to you. Just a quick note, genetics as a concept and what is in your DNA has been already uncoded not very far ago. Basically, the humankind spent more than 15 years and something like $9 billion trying to decode DNA, which was successful. Now, what we're trying to achieve is try to understand, okay, well, what's in that DNA, what actually specific behaviors, external factors, how do they govern something that happens to you on a personal level? So contrary to the popular belief, what basically the old idea that genes are set in stone is basically disproven. Whether you have or not have a predisposition for something now basically is more in your hands. And this is what we're trying to tackle with modern tools today. The importance of epigenetics, why it's so important. Again, I mentioned this, the Human Genome Project, where over 3 billion bricks or pairs defining us as a species have been already analyzed. It is important because we're now learning how to understand what's good or bad for us and how to tackle that. Basically, in pragmatic terms, now with the advent of the modern tools for data analysis and the way how we collect the data, it now allows us to not only create a personalized approach to diagnostics, basically where we live, how we live, but also develop something which we call personalized drugs, personalized treatments, and ultimately achieve a relative immortality. So basically, we now are aware what would be the interventions that might extend our health span, and not only to live longer, but also live better. Okay. We'll talk today about the different omics, and that's, we'll mention that a lot. Omics basically is the combining platform for the different studies, genomics, pharmacogenomics, phenomics. So basically, I'll explain those a little bit later. The point is that right now, after understanding the DNA, we've ventured into a field where we're trying to connect the dots between factors that have nothing to each other, structured data, semi-structured data, and we're now trying to develop a comprehensive approach, how to combine all those platforms that and focus on genomics and actually enable researchers to analyze different type of data, and also share this type of data with other researchers for speed up research and diagnostics. And this is why we're starting to talk about multi-omics. Okay, just a brief note on how are we planning to affect what is encoding in our DNA. We plan to tackle that through a process called DNA methylation. DNA methylation we can take as a tool. It's a simple biochemical process. It's basically a transfer of 4 atoms. What it does in layman terms, it allows something that's encoded in your DNA to occur. So it's a biochemical process. We know how to simulate it, and we now are starting to understand when you have, for example, an optimal methylation, it can have a significant positive impact on specific biochemical reactions in the body that regulate things like cardiovascular, neurological, reproductive, detoxification system. And this is something that we can only manage after understanding what factors positively or negatively affect the this expression. So basically, what is happening is, actually I'm going to skip that, is we're trying to find a way to take the concept of epigenetics and see a way how can we do actually drug discovery. This will be the focus of our existing startup, through analyzing various databases and understanding what AI methods and what combination of data will apply. So we basically can do 2 things. I'm a little bit shortening. It's what we're trying to do in very simple words. We're trying to take the human being, yourself. We're trying to digitize you to create a digital twin out of you. And also we're trying to digitize a specific drug for the concept of speeding up not only the diagnosis, but also the clinical trial research, which I'll also cover later. So basically, today tools allow us to compare large data sets with DNA methylation profile of genes that basically manage the process of aging and try to find specific clues for targeting the code of aging in a very, very personalized way. Now that we can understand your individual epigenetic landscape, we can basically track what is wrong or good with you, and what specifically is controlling your own biological aging. So basically, the final pragmatic purpose out of it is to figure out a way how to use machine learning as a subset of artificial intelligence, utilize large data sets, and start making predictions and start discovering basically patterns and apply it to specific diseases. Right now, we're trying to tackle 3 types of diseases. Number 1 would be diabetes, which is especially interesting for Bulgaria. Number 2 would be cancer, and number 3 would be different cardiovascular diseases. We believe that learning how to properly compare data, complex data, will be able to achieve unprecedented level of personalization, and this personalized medicine approach, connecting all kinds of different data sets, is what we refer to the application of omics data. Just to illustrate how complicated it can be, what we're doing right now, we're basically trying to combine existing data sets with creation of new data sets. So basically, the researchers doing that are called bioinformatics researcher. So basically what we do, we're trying to use multiple data from different platforms, such as genomics, genomics, proteomics, transcriptomics. So basically, genomics genomics is the science of how your genes express. What concerns us is pharmacogenomics. Basically, for genomics is a study how the different molecules, how different medicines are affecting yourself. And what we're trying to track now is basically how to combine all the different data we take, like blood samples, tissue samples, clinical data samples, clinical imaging data, all kind of metabolical data, and connect to various information. Can be structured, semi-structured, and unstructured. So basically what is happening is, now that we have tools, we have a new set of challenges, right? And our new set of challenges is basically both technical compliance and also, I would say, ethical. One of the technical challenges, for example, is that currently the so-called sequencers, the tools used to decode your DNA, can easily produce hundreds and hundreds of gigabytes of raw sequence reads per genome. So basically, we're now suddenly talking about terabytes of data. And one of the challenges is not only, how do you process this data, which we'll cover a little bit later, but also how do you upload this kind of data, right? So the reason we do that I believe that together with various, clinical and phenotypic feature, this data can improve our knowledge of complex diseases. But as I said, it started to present storage and analytical challenges. And this is what we're going to, analyze today, what kind of tools exist that make sense for us to use, and what is Microsoft basically doing about it. So to mitigate those data storage and analytical challenges, we started looking at cloud computing, right? And cloud computing geared towards high throughput experimentation, called multi-omics data, is also suddenly creating new challenges like security, confidentiality, and since the point is to not only try to look for patterns, but also try to connect to multiple sources of data. One of the problems that we're facing is for example, GDPR, or the data you acquire by clinical research. And the problem is not only to receive the patient's permission to use the data, but also how you data in a secure way becomes a challenge. One of the challenges of this multi-omics approach is that you can suddenly end up with a very, very sensitive data that can expose either the patient or enable or you can end up with a huge regulatory problem where you suddenly expose a whole set of people and actually enable somebody to access the information about certain individuals and predict things they don't want to share. But this is a separate topic. What I will try to do is concentrate on again the concept of approach of using the multi-omics, and I promised I'll try to explain what are the different omics all about. We're concentrated on several types. One is genomics. This is a study of genomes, the entire set of genes, the genetic landscape of an organism. What is good about it on a personal level, it only costs between $300 or $500. You basically take a blood test, and you can have your DNA completely decoded. And this is an important information. It comes to personalized medicine. The good thing is that for our research, we don't have to deal and basically chase different people and collect information about your blood samples. There are multiple databases right now and multiple projects that basically provide this data that you can play with and build your models based on something that already connects to a lot of people. Another important data set is referring to proteomics. This is the study of the proteomes. This is a set of the proteins produced by an organism, and it's an important input in the clinical trials. Transcriptomics is a so popular set of RNA molecules, this mRNA, RNA, so popular lately with the RNA vaccines against the coronavirus. What specifically concerns us, also as a startup, is pharmacogenomics. Is basically the effect of the variations that how your human genome responds to drugs. And this is the practical business application of our approach, basically explaining why do we do with it. So the point is that, well, for example, if you want to create a very powerful treatment against headache, what you don't want to happen is that your patients develop cancer, right? And well, this is a very rude example, but what we're trying to do is to find a better way of not only accelerating the research. Just give you an example. The usual time for a drug to appear from the laboratory on the shelf of your drugstore takes sometimes about 12 years, right? And an essential part of that is clinical trials, which can be 3, 4, 5, 6 years. And it takes sometimes 2, 3 to 4 years of preclinical trials. And this is what we want to tackle by creating the digital twins of the people, the digital twins of the drugs, and applying the concept of pharmacogenomics. We're trying to understand two things. We're trying to understand how to make it faster, as I mentioned, but also we're trying to de-risk the whole thing. So basically, again, how do you respond to specific drugs? We're hopeful now to simulate it in a safe way without actually exposing human individuals or animals to trials if, God forbid, they are dangerous. So, again, phenomics is also important. It's phenomics basically also refers to clinical trials. Phenomics is the set of phenotypic traits, such, for example, as comprehensive description of disease symptoms in a specific patient. Again, the whole concept is to tackle specific diseases. I mean, we can't cure, we can't sort immortality for the time being, but what we're trying to do is at least focus on the 3 popular diseases, cancer, diabetes, and cardiovascular. So it's all the type of insults and cardiac arrests. So challenges. So as usually, the more opportunities we create, the more challenges. So there are very, very specific challenges, although we know the advantages are quite clear now. Some of the challenges are, again, data privacy and security, right? They're actually probably the biggest threat to cloud computing. In the healthcare data analytics domain, specifics on authentication, authorization, access control, within the virtual network are very essential security concerns, including data leakage, loss issues. Second challenge is the infrastructure requirement for systematic analysis, for the advanced query of the frameworks of big data sets. Again, a lot of those big data sets can reach terabytes, right? Another challenge is that different omics repositories that needs to be incorporated to provide a reliable solution. So we're still working on standardized approaches. So, and critically, of course, that doesn't have to cost a lakh, so it has to be relatively affordable. So researchers can basically use that in a way so they don't have to worry about like low compliance, data compliance, or still avoid technical bias. So what we've been particularly happy to find about Microsoft is that Microsoft started to take care of that. I've been talking before about Azure Healthcare Cloud. Right now, it's worth mentioning that Microsoft is providing a specific solution called Microsoft Genomics. So basically, it is analyzing, it's helping you analyze and interpret data generated by modern genomics technologies using open source software, big data analytics, and machine learning services, all connected on Azure. So it's not only allows you to load balance and tailor your needs for power, CPU, GPU, but also is basically taking care of a system. So Microsoft has a lot of experience in running exabyte scale workloads, and since that Microsoft Genomics is on Azure, you have the performance of a high performance computer. Plus, you don't have to worry about the security. You don't have to worry about the connectivity and the compliance. So basically, the point is that you can use REST-based APIs to integrate your existing tools, simple Python clients, and basically connect in a way that guarantees that this is all going to be very secure, very stable, and you don't have to worry about the data being hacked. You can orchestrate very scalable workflows, basically directly, efficiently manage genomics pipelines, and most importantly, you can take advantage of specific tools, which we're going to explore real quick. For example, the genomics data lake is exactly the example of how to integrate various public data sets. A lot of those data sets we can now access for free and integrate in our genomics analysis workflow and application. It could be genome sequencing, all kind of data in all kind of formats, and basically we're currently researching a couple of those. I think my colleagues Ivan and Matthew can share what we've used until now. So to give you an idea how developed that is, probably one of the most well-known projects, they're called the 1000 Genome Projects, that run between 2008 and 2015. It's so far the largest public catalog of human variations in genotype data. Right now we're talking to more than 800 terabytes of data, and it's being updated pretty much daily. So you can see the genomics data lake, the different tools it seamlessly integrate. So basically, what you can do with that is you can greatly improve the accuracy of your machine learning model with publicly available data sets. And I think Ivan can share a little bit about the bias and the data bias that we run into. For example, trying to create basically accurate analysis, we found that we don't have the data of black-collar people, for example. Why? Because people in sub-Saharan Africa have almost no access to clinical, to regular clinical examinations. So you can imagine that if you live, for example, in Switzerland, where people really take care of their health, there is a lot of data available. But not to carry away, the point of this is save time on data discovery, preparation by using save data on preparation, because you can use curated data sets, basically it allows you also to manage seamlessly without worrying too much. For example, how do you manage your object storage, right? For example, this is managed by the Azure Blob Storage. So basically, it integrates all your archives, data lakes, high-performance computing, and machine learning. So basically, it helps you create a data lake for your analytical needs, and it basically provides the storage to build powerful cloud-native and mobile apps in a very optimized way. It's basically like the blob storage, for example, is built from like ground up. And again, the point is that first, it takes care of the security of the storage, and it's basically is a good cornerstone for serverless architectures like Azure Functions. What's also important is that it supports the most popular development frameworks. So basically, it doesn't matter if you use Java, .NET, Python, or Node.js. So it's very universal, and so you don't have to also worry about what kind of stack you have access to. Basically, it's pretty universal. Just a quick word. I won't cover that in too much detail. You're all well aware how Azure HPC, high performance computing, works. Again, for our genomics type of research, it's super important to be able to scale up or down and use cloud computing. So basically optimize performance, CPU, GPU, without worrying about, end-to-end workflow agilities, and without worrying about the need to build, complicated machinery, just to be able to achieve something in time, especially given nowadays all the problem with the chips and access to computing. Again, I'm pretty much almost done with that. What are the challenges? First, we're still struggling with the bias. Well, the large databases, they still require cross-jurisdiction collaboration, especially if the diseases we're trying to tackle are rare. Still, we're struggling quite often with lack of data, right? So to train our machine learning algorithms to function effectively, we need more data. It's not always available. And combined with the prediction of bias, we always have to question ourselves, well, how are we going to tackle that? That basically completes my overview. Thank you for the interest, and I'll pass the word to my colleagues, Ivan and Matthew. Thank you for listening.
Let's see. Okay. Yes, I think we're live. Yes. Okay. Hi everyone. I hope everyone can hear me. Cool. So my name is Ivan Tsenov. I am the co-founder of Figure Out AI, which is a company which aims to democratize AI in Bulgaria and the Balkans and in Europe as a whole. I also work at Anthill as a data science consultant, consulting different businesses that want to utilize AI in their day-to-day works. And I've studied mathematics at Tufts University in Boston, where I was granted the #1 student in maths award. And I'm going to talk a little bit about what we've done, what we've achieved in Epics, and where we're hoping to go next. Andre already talked a little bit about methylation aging clocks. Those are essentially epigenetic formulas for determining a person's age. Hopefully their biological age, but currently people are trying to correlate epigenetics with the chronological age. And the #1 current state-of-the-art model is a paper released in 2021 called Deep MAGE, that stands for Deep Learning, Methylation, and Aging. Though their paper improved significantly on the state-of-the-art by introducing neural networks to the methylation aging methodology. And they achieved around 3.9 years of average error in predicting a person's age, chronological age, based on their epigenetics. So essentially, they take a blood sample, they make a genetic sequencing out of that blood sample, and they're able to predict with significant accuracy that person's age. So this is very important because it speaks in the way that epigenetics is related to your biological age as well. So it has been shown before that epigenetics is actually determined by your environmental factors. So it is very, it's sort of, we're at the cusp of realizing what our bodies, how our bodies are aging and what we can do to slow or accelerate that age. So their paper actually had some flaws, and we were actually able to swoop in and sort of see what we can do better and actually make the model a lot less biased and a lot more accurate. The first flaw they had is the way they tackled data. They usually had a lot of missing data values and also a lot of duplicate data, which it introduces bias. So if you're actually working, for example, with patients from all the way from 0 years old to 80 years old, and you have more 40-year-old patients than anyone else, the model is going to be very biased towards that age group. So that's something we realized, and we tried to tackle that and sort of flatten the bias so that the model is a lot more accurate for all ages. And this, obviously, the bad data, it results in an unbalanced distribution of error, and we're trying to essentially flatten that distribution. So we set out to improve the state of the art, and we achieved that by focusing on the data very, very diligently. We set out to clean the data through a very standardized pipeline, so every data goes through the same set of functions and manipulations. That way, we assure that different data sets, because we are actually working with more than, I believe, more than 20 or 30 different data sets. And those different data sets have been normalized differently and have all sorts of inherent biases. So we started from the very raw data that's taken straight from the blood sample, and we decided to make sure we normalize all the data uniformly, and then to perform all sorts of manipulations, which actually my colleague Matthew is going to talk a little bit more about. The second action we took to improving the state of the art is gathering more data. So the Deep MAGE methylation clock was built using around 5,000 to 6,000 samples of data, of healthy person data. So we decided to see what else, what other data we can find, and we actually managed to almost double that. So we're working with around 10,000 samples of very clean data, and we actually took a further step, which is we flattened the age distribution of training data. So essentially what that means is if we have 10,000 samples, but then we have 500 more young people than old people, it's actually better to cut off some of them, so maybe 300 of them, so that the age distribution is actually flattened. And that way the model doesn't have an inherent bias towards younger or older people. And as a very famous AI entrepreneur and scientist called Andrew Yang is sort of basing his whole messaging around is data-centric modeling. AI has reached a point where modeling is no longer the hot stuff. The hot stuff is data. So improving the model can only get you so much if the data is messy, if it's not uniform, if it's biased in all sorts of different ways, and if it's if there's not a lot of it. So we're really concentrating on getting more data, making it cleaner, making it better, and that's how we're tackling improving the current state of the art. So here are some graphs that show how much we've improved the modeling. So on the left, you always see the deep mage model, and on the right is the epics model. So what we've been able to do with methylation aging. So on the left side, you can see that deep mage's error is very uneven in terms of different age groups. So as you can see, the age group of 70 actually has an average error of 8 years, whereas the age group of 0 has an average error of 0.5. So this is obviously an issue because we want to be able to tackle all sorts of demographics with our potentially our product or with our brand. So it's very important that we flatten this out as much as possible. So here on the right, you can see how much we've been able to do that. Actually, the error for some of these age groups has increased very slightly, which is around the 40 years. Our error is a bit bigger, but on the flip side, the error for older people has actually decreased a lot. So it's sort of you cannot have everything. If your model is targeted towards younger people, it's going to perform better for younger people, but you're not going to be able to target the older demographic that way. But with our model, we're able to uniformly sort of target everybody. And this is very important because actually it's older people very often that are going to need to sort of keep in check their biological age. So it's very important that the older a person is, the more accurate the model becomes. So what we just saw, actually, let me go back. This is the distribution for healthy people. So for healthy people, we're actually expecting that there is not as much sort of distribution in the error, whereas for people who have certain diseases, we're expecting a lot more ups and downs in terms of biological aging. So if a person, for example, has cancer, their body obviously ages a lot faster. So here are the graphs that have to do with our different cases and how that distribution is tackled in deep mage and in our modeling. So you can see that for for people who have certain diseases, their model actually performs significantly worse when it comes to younger people. So for newborns, it actually gives an error of 8 years. And what's very interesting is that it doesn't actually give them an error of 8 years in the positive direction. It actually gives -8 years or -10 years. So you take the test, you go through the model, and the model tells you you are actually -8 years old, which actually makes no sense, and it actually speaks to how big of an impact unclean data can have on your modeling. And it's very important to say that we basically haven't touched the model at all. This is almost exclusively just the different data and the way we've tackled data. So on the right, you can see that our age error increases very linearly with age, which is something I'm going to talk about in a little bit, but it's something we're expecting, and it's something that's very, very, very promising. Even though our model trained with twice the data, and the data distribution is more level and more uniform, the overall error is still 3.9 years. We actually haven't been able to improve the overall error in the model. So the usual way to sort of interpret this is to say that the AI doesn't do its job, but it's actually a lot deeper than that. It actually has to do with the way the data is structured by itself. So the data actually correlates epigenetic aging with chronological aging. So there is a certain overlap in that, but there's also a bit of error that can never be completely dismissed, because there is a difference between biological and chronological aging. So that's kind of an exciting place to start, because if the correlation between our model and the chronological age was 100%, then that means there is no difference between biological and chronological age. But in our model, there is such a difference, and it doesn't get smaller with better data or with better modeling. So what this means is that it's inherent in the data. And this means that epigenetics is not chronologically determined. There is stuff you can do, ways you can live your life, and diseases that can affect your epigenetics in a way that it actually differs from your chronological age. So the key is somehow in the error, and we have to explore that error, of the error of our model, to see exactly how we can improve it and how we can sort of correlate biological aging with our idea of biological aging, which is I'm healthier, I'm gonna live longer, and stuff like that. So it's actually very good that we're not, even though we've doubled the data, the overall error does not fall down. This means that the way we live our lives actually determines a lot of the way our body ages. If it was 100% accuracy, then your body, there is something inherently in your body that's telling you, okay, you're 75 and there's nothing you can do about it. But the fact that we have this buffer of on average 4 years of age means that on average a person is either above or below their chronological age in terms of biological age. And what here's as I was going to say, this is why we're very happy that we've reached a linear increase in aging with time, in error with aging, sort of. The higher a person's age is, the more it matters how they've lived their life or what diseases they have. So it's very good that that the error of the model increases with age. This means that it's capturing the fact that people live in a different way. And the final thing I'm going to talk about before I give the word to my colleague is that we've actually been able to see how different diseases affect your biological age a lot better than deep age. So on the left is deep age's distribution of cases and different diseases and how they've affected the error. You can see that there is not a lot of there is a lot of clustering of different diseases in the same spot. So different diseases actually are not separated by the model, which makes no sense because, for example, cardiovascular diseases age you in a certain way, and psychological diseases are going to age you a different way, and so on and so on. And cancer is going to age you a third way. So on the right, you can see our modeling, which actually separates a lot better those data sets. So the different colors actually correspond to different diseases, and you can see that, for example, the pink data set, which is actually it's actually colon cancer, is very separate from the light green, which is actually schizophrenia. In the deep mage model, it says that colon cancer ages you the same as schizophrenia, which is obviously not right, because they have very different onsets of disease and obviously very different lifestyles associated with them. In our model, those clusters are a lot more separated, so we're actually going to be able to say, okay, this disease is affecting your aging this much, and the other disease is affecting your aging by another amount. So this is very, very good, and we're very happy with the way we've progressed, and we're hoping to get even more data and get data about different diseases and separate out the biological factors from the chronological factors even more in the coming years. And now I'm going to give the word to my colleague Matthew, who's going to talk a little bit more about the actual processes that have gotten us to this point.
Hello, hope you can hear me. My name is Matthew. I am the other co-founder of Figure Out AI. I am a PhD student in physics at Cardiff Uni in the UK. And my focus there is largely on computer vision and machine learning in electron microscopy. So I'm going to try to summarize our principles of work here. And those are based on three pillars, which are using the state-of-the-art of gathering clean data, controlled data, and also automation. And now, why is that important? This is a life cycle of a machine learning model as it should be, because most data scientists, they do their R&D, they make their model, they make the data that they feed into it, but everything is merged into one single process, which is problematic. It's problematic when you're trying to make a product because you try to introduce new data, but you can't be sure if you're going to introduce bias with it, for example. You're trying to change the model a little bit, you're not sure whether that is going to break everything or not. So we are trying to get the practices from software engineering into machine learning here and automate everything, make it modular, make it controlled, and make it versioned. And as you can see in that graph, it is not just a single process that we go through once. It is a cycle, which allows us to control different updates. It allows us to scale our product, and it allows us to make changes. Extremely important when we're actually start having users and we actually start scaling up. So a few of these steps are, well, we've already mentioned. Those are the data, how we work on that, and the model itself. So let's move on to the second pillar, which is the data set. We need a healthy, controlled data set. So what we've done is we have made a data set process, a data set life cycle, which ensures that we are only dealing with quality data, because as good as a model is and as modern as a model is, it is only as good as the quality of the data you feed into it. So our data passes by a renormalization, which happens to the entire data, removing the biases of using different researches, different studies, and having data that has been processed differently in all of them. This will definitely introduce biases. So what we do first is we normalize the data as a whole. We restructure it, of course, to make it usable for our specific cases. And that is the pre-processing that we do. Then we clean up the data. This is done by removing the duplicates, as Ivan mentioned before, and also removing missing values, which we can sort of express as noise. So removing duplicates is another way to introduce bias, which is bad. And removing missing values, in other words, controlling your noise, is super important. Noise can be healthy for a model, sort of forcing it to deal with it, but it can also be detrimental to it if the noise follows a pattern or the noise is just too much. So this is something that needs to be controlled very well. After that data quality check has been done, we move on to dealing with the data itself, kind of the data engineering bit of the process, where the structure of the data becomes important because we have a lot of data. We have about 10,000 samples, but each of these samples contains between 450,000 and 850,000 points. And that produces an imbalance. What we need to do is make that imbalance smaller. And this is done by selectively reducing the amount of data points that each sample has. And we do that by employing another state-of-the-art process, which I'm going to briefly show in a bit. But after that data trimming has been done, we have two benefits. After all these processes, our data is clean, our data is controlled. All the new data goes through the same standardized process, meaning that we cannot really introduce biases in that way. And then also the data becomes significantly smaller, which enables us to have an efficient model, which enables us to have larger batch sizes and essentially play around with the model itself, not being limited by the size of the data. So this is the second important thing that we deal with and we try to do properly. So the feature selection, which is the reduction of our data size, I just wanted to show quickly because it's a little bit specific. And it is somewhere where we gain a lot of power as well, because for that we also use machine learning rather than the classical way of simply plotting data, having a look of graphs and sort of linearly expressing dependencies in graphs. This is fine, but when we have such big data sets that are so complex and so abstract, we need something more. And that something more is called deep feature selection, where we use a neural network which starts with a sparse layer, meaning that each data point is connected by a single weight to the rest of the network. And what that does is it opens the black box. First of all, it makes the data less abstract. We know now which data point is important and which isn't just by looking at the weight of this network. And it is super powerful, reducing our data from about 450,000 entries to roughly 1,000 or as much as we want. The other powerful thing about this is it was initially designed for DNA sequencing, which is very, very close to our epigenetic data that we deal with. So this is how we do our deep feature selection, so how we reduce the sample sizes. And all of this, if done right, the automation, the state-of-the-art models, and the data quality, we can produce robust models. We can produce automated pipelines that can sort of take care of themselves. And we can use AI to get data from many, many different places. As Andre mentioned, we want to utilize not only epigenetics data, we want to utilize all the other omics. We want biomics, physiomics, and everything else that a patient can have examined. And getting everything together and crunching it down using AI can result in a very convenient and nice way to improve the efficiency of professionals, a nice way to tell a patient what is going on with them, because it is going to be intuitive. And this is an example of such a structure. This is called digital twinning, and this is an example from multiple sclerosis, which shows how we can get data from a lot of patient a lot of patient sources, crunch it down with AI, and then make it into a very convenient, very clear, and very intuitive dashboard for both the physician to make their diagnosis easier and more informed, taking into account more variables, and also improving the communication with the patient himself. And this is just one example of how we can utilize what is currently coming out, what is the current state of the art, to make the product to improve the lives of people. So epigenetics in particular is a largely growing area of study. It grows exponentially and it doesn't seem to be stopping. So what we have is a lot of resources and a lot of good research that we can base our products on. Combine that with a good policy and a good principles of work, and we can produce some really nice, really useful products. So these are all the diseases that have been examined recently with machine learning and using epigenetics, which shows that epigenetics contains data for a lot of different diseases. It can help in a lot of different ways, and it is a nice way to collect everything together and examine it as a whole. So thank you very much for listening. And if you have any questions, we're more than happy to discuss. Thank you very much to our sponsors as well for the opportunity to present. So if we can answer any questions.
Thank you very much.
Thank you, Ivan and Andrei. It was really great presentation.
Hello everyone from Lisbon. Here we are on Lisbon edition of Global AI Bootcamp, and here are organizers and speakers from the event in Portugal. Guys, you can say hello. Yeah, it is really great that we have this opportunity to organize together one event in different locations, and I'm really glad that we can do this internationally. I would like to say one time more thank you to all organizers worldwide, global organizers, and our friends in Lisbon. Thank you. Thank you very much in multiple languages from all of us. Obrigado. Thank you, guys. We will continue with the last session about Azure Stream Analytics and anomaly detection now. Okay. So I will share my presentation. Thank you. Today we will talk about a very interesting scenario where we can use Azure Stream Analytics with different types of machine learning and in general AI related functionalities using embedded capabilities of Azure Stream Analytics and also general approach how to use these with machine learning services and also with Azure Cognitive Services. Let's start with some general overview what we have in this presentation. So we will talk again about IoT. Why about IoT? Because this is one of the main scenarios when we have Internet of Things. And we will go later into main scenarios related to usage of Azure Stream Analytics. We will see how to use Azure Stream Analytics with machine learning. Also, we will use Azure Stream Analytics embedded capabilities, especially for anomaly detection. We will make some parallel with what is available for anomaly detection now. Probably some of you know about my presentation from the last year related to Azure Digital Twins and anomaly detection. So I did some research regarding to usage of anomaly detector service, and now we'll do some parallel between this approach and how we can use Azure Stream Analytics with embedded machine learning capabilities. Few words about Internet of Things. It is not a new topic. Internet of Things is one of the fastest growing parts of IT industry and in general of technology, where connected devices are growing and number of connected devices is rising in exponential scale. So we have billions and billions connected devices, and it is expected after 2-3 years to have between 75 and 100 billion connected devices. It could be now almost everything, not just phones, computers, board computers, wearables. Almost all vehicles and equipment now can be connected, and it stay connected because we need to have information about how systems work and to have some analysis and to make based on this analysis some decisions where predictive analytics now is one of the most important and one of the parts where we can bring additional value to the business, because predictability is very important to decrease the cost for eventual maintenance and possible issues in the solutions. IoT is applicable in almost all domains, and we will not touch some specific domains. It is almost everywhere, using different kind of scenarios for logistics, automotive, vehicles, agriculture, smart metering, smart energy, smart city, healthcare, insurance, and many other areas. We will talk mostly about AI, IoT, and especially data streaming and also anomaly detection in the context of Azure, the Microsoft Cloud, and Azure, as any other cloud platform, is a moving target. That means cloud platforms are changing continuously. That means what we are talking now probably will be replaced in the future with even more modern, more effective, uh, easier for use solutions. But we are talking what is exactly now. One of the good advantages working with big cloud platforms, and especially Azure, is that we have a lot of materials regarding to reference architecture. Azure reference architectures allows to make easy creation of IoT solutions. What is important here? You can follow good practices to make workable solution, which is quite good and compatible. It could be not the most optimized in any case, but it could be good enough to have no design and strategic issues. So this is one of the most important following good practices. And we have different scenarios regarding to IoT solutions, but we will have focus now mostly on data streaming. First, we have different types of devices. We have connected devices which are IP enabled. That means you can connect these devices using TCP/IP or any another network protocol on top of this one. We have options to change our protocols from the cloud gateway side and from the device side. If we are using field gateway, that means it is possible to have on device side also devices using different protocols, but at the end, communication between devices on site and backend should be compliant with several protocols supported from Azure IoT stack using HTTPS, MQTT, AMQP, for example. Cloud Gateway is very important part of any strategy, especially for data streaming. It is the same, and you need this service to establish communication between backend and devices. Azure IoT Hub is the default cloud gateway service for Azure IoT stack, and we will have some samples based on this implementation. We need a service for stream processing. Historically, it is possible to have different solutions here. It is possible to have different streaming services from different vendors, open source solutions. But if you consider something out of the box with low cost, stable, easy for use, Azure Stream Analytics is one of the most applicable options, and we will be focused on Azure Stream Analytics because there are a lot of options to have also integration with AI. And when we have stream processing, we can have several different outputs. From one side, we can persist long-term our process data into different storages, depending on the volume and other non-functional requirements. We can have different types of storage. Usually, the best options are to have good balance between price and options to use searching with indexing for this kind of storages. Again, we have many scenarios. Analytics and machine learning is another important option, and analytics and machine learning is exactly what we are considering in the context of this presentation. We can have different kind of background applications. Also, we can have direct output to BI and reporting tools like Power BI, for example. We can have output to different services which can have also different types of data processing. When we talk about IoT Gateway and IoT Hub, it is important to know also that we can have different type of protocols and approaches for communication between devices and backend. We can have even options to serialize using different protocols, part of data, for example, using protobuf or another technologies. But when we need to have data stream analytics, we need to deserialize data which need to be processed. So this is one of the important things. And of course, it is important depending on what kind of scenarios we have and from where and how we collect data. It is possible with Azure Stream Analytics to have really very different scenarios. And here is an overview of different scenarios, not only for IoT, but also for other use cases, to be clear where, what, and how we can do. One possible scenarios where we have stream analytics which handle data from different sources. IoT hubs, for example, from devices and sources from outside, and event hubs where we can have pretty similar mass message spreading more often nowadays in restricted networks. It is possible to have mix between different sources and to have common analysis, or to have so named complex data processing. And we can have output to some BI or reporting tool. Of course, we can have many components added, but for real-time dashboarding with different sources, it is more than enough. You need to have just stream analytics, you need to have sources, IoT hubs, event hubs, storage, Azure Storage are supported as input for Azure Stream Analytics. If you need to have something specific, you need to have also some kind of transformation and to persist this data, for example, into storage and to read from the storage data using available Azure Stream Analytics capabilities. Power BI support by default visualization of data, processed data from Azure Stream Analytics. So it is possible, pretty easy to have such scenarios. You need just to configure the output of Azure Stream Analytics to specific Power BI using account with applicable credentials and to have workspace where to persist this data. Let's see next scenarios. If we have dashboards, not just live data, but dashboards where we can have analysis of historical data, then most applicable is to persist data into database. Depending on what kind of data we are using and our scenarios can have different best options. Azure SQL database is one of the good options because relational databases are easy for use. Learning curve is not big and Power BI is perfectly integrated, but you can use also NoSQL databases like Cosmos DB. Power BI works also pretty easy with Cosmos DB. Let's see next scenarios. Well, we can have scenarios where we will integrate data generated from devices and after that processed via Azure Stream Analytics with other services. Usually, when we have distributed solutions, we need to have asynchronous integration and to rely on eventual consistency. So in this case, messaging services are one of the most applicable options. We can use Event Hub, we can use Azure Service Bus, and of course, always we can have as glue also Azure Functions. So this is one of the most applicable scenarios also. If we need to have direct communication with another service, it could be with Azure Function. Usually, messaging service is the most important component here if we need to have asynchronous communication. We can have, of course, mix. It is possible to have Azure functions which are triggered from service bus and different complex scenarios. It is possible to have web applications where we can have visualization of insights generated from data transformed from Azure Stream Analytics. Usually in this case, we can have notifications using SignalR and Azure functions. We can use, of course, alternative options, but this is one of the most popular options. As we already discussed, it is possible to persist data in different type of storages. We can read this data from app service and to have some real-time applications. This is also one very, very popular scenario. In real life, it is possible to have scenarios where on several steps to have data transformation. So you can have one step where from several sources data is collected. We have some transformation. After that, we can have integration via messaging services of this data with other services. We can transform data several times using different jobs depending on scenarios. We can have after that data persistence and to use this data in some live applications based on app service, for example. Often we need to have reference data. Reference data is one also very important part. Reference data can be data persisted in Azure storage or SQL database, and main goal is to have additional data which can be used to enrich our messages or to have a relation with another information which is important. This reference data can be based also on data which is already processed and analyzed. So we can have continuously update of this reference data, and based on this, our processing of data using Azure Stream Analytics can be changed because our reference data continuously will be updated. This update can be done in different ways. Quite often, Azure Data Factory is one of the good options to use this reference data. Another important scenario is when we have machine learning. When we have machine learning, we can directly call machine learning functions from Azure Stream Analytics. And here are many details. From one side, we can have calls to services where we have published machine learning models. It is possible to be also democratized AI, where instead custom created or based on templates machine learning models just to have for more often used cases cognitive services. It is possible to use also embedded capabilities of Azure Stream Analytics. So this is probably the most important related to main scenarios when we have data streaming and usage of Azure Stream Analytics. Again, we are focused on this service and how to integrate this service with AI. But in real solutions, you can have quite interesting diversity of scenarios. What about integration between Azure Stream Analytics and machine learning? One possible option is to have integration where we implement machine learning models and we implement these machine learning models like user-defined function in our Stream Analytics job, and we have at real time calling of these functions and actual implementation of such kind of solutions. To be possible to do that, we need to create models and to deploy these models as a web service. I will do an overview because it is not possible for the short timeline to have practical demonstration of everything which is needed to create end-to-end such kind of solution. So we need after that to configure our service. We need to have sample inputs, outputs, and for a huge load, it is good to host this model into AKS, for example, Azure Kubernetes Service, or another microservices solution. The point is that if you have just single service where we deployed our model, and we have Azure Stream Analytics, where Azure Stream Analytics is making quite often calls, it will be difficult this service to scale, and we have quite high probability to be in situation where to reach some limits. So we need to think about possibility to scale these services. And it is possible to create Azure Machine Learning Service, to generate template, to update after that this template using Visual Studio or Visual Studio Code. And after that, you need to have specific queries in Azure Stream Analytics. Now we will be focused more on anomaly detection. It is, at least for me, very important domain because, as I already mentioned, anomaly detection is one of the most important parts related to predictability and what we have. And we will cover in general things about anomaly detection, what is possible to make with Azure Machine Learning and cognitive services. And after that, we will go to embedded capabilities of Azure Stream Analytics. This is the main goal of this talk. So first, what is anomaly detection? Well, anomaly detection is a specific group of analysis from the statistic point of view. The main goal is to analyze data series and to discover specific anomalies. That means not usual values regarding to specific criteria. Microsoft offers anomaly detector service. Anomaly detector service was announced more than a year ago, probably in 2020 for the first time, or 2019. And initially, it supported only univariate anomaly detection techniques, and after that, it was extended to support multivariate anomaly detection scenarios. I will try to explain more about this. Before to continue, you can use anomaly detection for many different things. You can apply it for climate change, for example. You can apply this for healthcare, but more often people connect anomaly detection with manufacturing, where you produce different units of specific product, and you can have analysis if there are some changes. You can have different specific analysis in this area, depending on what you understand as anomaly. You can have fraud detection, and you can have many related scenarios. Microsoft offers two different techniques, as I mentioned. Univariate anomaly detection is focused on anomalies in individual metric. That means specific time series. It is more simpler, and it can be analyzed easier. Where API expose two different ways to analyze anomalies. You have option to try to make analysis for the overall series, or to try to analyze changes in the last points. When we are talking about univariate anomaly detection, it is exactly about finding specific anomalies in one time series. When we are talking about multivariate time series, we have much more complex models. We can have many time series, and based on these time series, we can have analysis applicable for much more complex scenarios. We can have modeling of complex processes and complex systems. So multivariate time series are applicable for such kind of analysis, and it is really the most complex scenarios which we are looking for. We will see later that usually when we have new services related to anomaly detection, or services where we have introducing of these functionalities, initially always first implementations, first previews are related to univariate anomaly detection to be possible to have the simplified scenario, and after that you can expect implementation from the vendor of multivariate support. So how anomaly detector works? Anomaly detector as a service is actually Azure service, part of cognitive services, but you need to create it separately because it is specific type of cognitive services, and it exposes REST API. You have no need to create a model. You can just use available already trained models, so you are getting everything out of the box. And there are different algorithms which service is taking for you based on internal analysis. So we have gallery of algorithms, and it is possible to choose, not you to choose, but service to choose the most important algorithm for this. Usually when we have need of analysis with anomaly detector, there is classification of time series, and based on classification, it is possible to get internally one or another algorithm. So this is the main flow. First is needed to analyze time series to extract data. This is what the service is doing. It is the first step. After that, service is choosing the algorithm from algorithm library, and um, it makes first most raw analysis, and after that it makes additional several steps with possible application of filters. So this is something which we have using standard anomaly detector service. How it works for Azure Stream Analytics. Azure Stream Analytics offers two different methods for anomaly detection. So it is possible to use embedded functions. Anomaly detection, spike and dip. That means if you have small, higher or lower values significantly different from the rest, and we can have also change point. Change point means that there is a change of the values. You have some kind of changing of the significant change of the whole values from some specific moment. So this is what we have as analysis for now. These embedded functions probably will be extended. It is something which is relatively new. I think that it is supported from less than 2 years, but not from the beginning of implementation of stream analytics. And here we have specific details because Azure Stream Analytics is using windowing, and it apply this analysis for specific window. And this window is sliding window. What kind of windowing functions regarding to analysis we have in Azure Stream Analytics was considered in different presentation. It is something which requires more time if we need to go into details, but Azure Stream Analytics is offering several windowing functions. And analysis considered event history over the sliding window timeline. This is the most important. It is not so complex for now, but it is something which really can be used for practical tasks. And usually when we have calling of these functions, we can configure the size of the window also to tune the sensitivity of our analysis. Gaps which are in time series can be also regarding of lack of some data. So we need to know quite good also our data sources, what is expected to be possible to apply properly our analysis. Again, what is spike and dip? You can see such kind of scenario here. It is possible if you have, for example, significantly higher value of specific sensor, which is probably not expected. It could be because of different things. Imagine, for example, that you have temperature sensor. If you have such kind of spike, It could be because something wrong happened, and it happened time to time. If we find some kind of anomaly, we can in advance try to check and maintain our system. And it is possible to have queries, SQL-like queries in Azure Stream Analytics, where using these functions with specific parameters to try to have good prediction. For example, here in this query, we have detection of spikes and dips for temperature, where we are looking for 95% of confidence, and we are considering history of 120 events. Of course, this can be changed. And we can have from our input such kind of analysis, and after that to create our data structure, which will be sent to the output. This is the main idea when we have such kind of solutions. Change point is also interesting scenario in anomalies, where, for example, you have expected values with specific range, and after that, these values are changed permanently in some different scope, different from the previous one. Usually in such kind of things, we can consider that there is some trend. For example, something doesn't work very good. Again, it could be temperature, it could be no sound, it could be vibration, it could be different kind of metrics. In similar scenarios, we can see that something is happen, probably solution continue to works, but it works for a longer period of time with different configuration. Not it is not like spikes and dips. And we can use here anomaly detection change point operator, for example, and we can have such kind of level change for in some scenarios. That means something change the parameters of the system, and after period of time it could stay again close to the initial one. It is possible to be also different scenarios where we have trend, we are changing the values till we reach some specific threshold, and after that we are seeing again values close to initial expected values. And we can have scenarios where we can have prediction of change point cases. For example, we again can consider number of events. Here we need to consider the confidence, and we can also have here the time units and timeline which is needed. So such kind of scenarios can be implemented where performance characteristics are very important. That means history size, how many events we have, because this kind of analysis requires some resources. So it is analysis which out of the box is done from Azure services via these functions in Azure Stream Analytics, or that means you indirectly are using some AI capabilities from predictive analytics for anomaly detection, but you have no need to have specifically created services for this in a way which we discussed for anomaly detector service. This is the most important. And depending on window duration, event load, and partitioning, because we can have partitioning for anomaly detection to have parallel analysis, we can have different performance characteristics. And you can see usually based on different scenarios, we can have specific performance KPIs. It is possible to have throttling if we have very high load. It is something which prevents Azure Stream Analytics from general failure. So it is something which actually is implemented for any cloud service. Now let's try to have some demos. I will try to stop my presenting mode and I will move here one of projects which I already prepared. First, let's see how works anomaly detector service, because it is something which we discuss in advance before to go into Azure Stream Analytics and embedded AI capabilities. I will share Azure Management Portal, but I will open one new tab, and what I would like to show, I will filter my services to choose what I have created regarding to cognitive services and anomaly detector. So we have actually from one side pretty similar services, but you need to create anomaly detector service separately. What we have as project, it is already running. I will try to explain in advance. We have actually connection to our anomaly detector, but because in the sample is using form, I will just start now the form of the demo application and will demonstrate what happened. Give me a few seconds. We need to load the sample application. Because I'm running several additional prepared for this presentation demos, it took a little more time. Okay, so we have this URL and subscription key. Where is this in our anomaly detector? So our anomaly detector is created like separate service, and we have keys and endpoint. If you consider cognitive services, it is actually pretty similar, but anomaly detector expose specific API. When we need to create a new service in this from this type, we just need to this to choose anomaly detector. Anomaly detector is created again separately. You need to choose all standard things which are related to subscription, resource group, region, absolutely standard, West Europe, and you need to choose only one pricing tier, need to choose network identity and all these things. But we have already created similar service. So this service is called from this application, and when we send request, actually we see here that we have some response. It is a REST API. You can check it also using direct call against API or using SDK. This is something which can be integrated in different applications. We had similar talk about how to use this with Azure Digital Twins. What will happen if we need to create directly such kind of solution in Azure Stream Analytics? I prepared one simulator. Simulator is making requests via IoT Hub. These requests actually can be controlled. You can have spikes and dips. You can make, for example, different duration. You can make of the pattern. You can have also different configuration regarding to time, which is configured for repeating of the whole pattern, and need to add here connection settings for device in IoT Hub. There is creating device AD simulator. Let's show you how it looks. So I have created IoT Hub. Let's go to show you. And added in devices additional registration of device which is used from the simulator, AD simulator. Got from here primary key, and connection string is generated automatically, but if I'm choosing such kind of helper, you can see this is actually the URL host name. Where is the IoT Hub? So we can send requests. How looks our IoT Hub load? Let's go to our IoT Hub and to see what we have now here. Let's see. Events. Total telemetry messages. For example, you can see here that we have last minutes relatively high number of messages. Let's now see what we have, like Azure Stream Analytics. Like Azure Stream Analytics, we have the following configuration. We have input, where for our input we have input from IoT Hub. I already created it. As you see, it is possible to have, let's zoom it, standard inputs from 3 different sources: Event Hub, IoT Hub, and Blob Storage, and reference input from Blob Storage or Data Lake Storage second generation and SQL database. We didn't make anything specific. It is absolutely standard configuration. And we also configured output. In the output, Power BI is used. Why? Because it is easy to demonstrate with Power BI how it works. It is pretty easy to make it understandable, at least for our scenarios. What I have as Power BI. So we have already created some dashboard. Of course, I will try to demonstrate this. We'll add some tile, but let's first see what we have here as queries. So solution is running because I wanted to have some number of events in advance, and I implemented this query with analysis for spikes and dips, which I already show with 95% confidence, with 120 events. Here, if we have too long timeline or too short timeline, we can have loss of some data related to analysis, or we can have performance issues. So it is pretty important to be with good understanding about parameters. And you see that here we have this analysis, and after that, here we are using what is generated in this step. How to make live dashboard? Of course, it is just one of the possible options. You can add tile. We need to have first created workspace. We need to create dashboard, and in the dashboard we can add tiles. And because of good integration between Azure Stream Analytics and Power BI, we can use custom streaming data from real-time data here. Next, we have already recognized data set generated in my output configuration from Azure Stream Analytics. We are choosing this, and we can choose here, for example, line chart. We can have different configuration here, depending on what we want to have, as you see. And we can see here, create such kind of component. So it is possible to have output to different services. Just here was easy to demonstrate everything with live dashboards in Power BI. What is the most important, which I would like to summarize in such kind of scenario? The most important is that you can have pretty easy anomaly detection just using Azure Stream Analytics for many different often seen use cases. So please consider this and take the main advantage of latest technologies. No need to create custom machine learning models, no need to make even anomaly detector service. I will prepare soon presentation where to compare with specific examples how accurate we have results using all these different approaches, but it will take more time. Session need to be a little bit longer. Hope this will be in the next few months, and we will go back to anomaly detection. That was the most important from this presentation, and in the end, it is good also to let you know that we will have Bulgarian edition of Global Azure in Bulgaria on 14th of May. This global event will be held mostly between 5th and 7th of May, but because of holidays in our country, we discussed with global organizers and Microsoft, and event will be held in the mid of May, on 14th of May. So we will have a lot of content related to Azure and AI, and I hope that if you join this event, hopefully in person or hybrid, depending on situation, you will learn a lot of new things about Azure and Azure AI. This was the most important for today. And at the end, I want to say a huge thank you to our team, especially to Stefka and Value, who supported um, everything regarding to administration of the tracks and help a lot. Also, huge thank you to all our speakers. Our speakers are community contributors. They do this because they like to share their knowledge. And of course, thanks to everyone who joined this event. We will stay in touch. I will share a lot of information. Our team will work to have updates related to next events. We are preparing also IoT and AI event in mid of September. The target date for now is actually, give me a second, 17th of September. So hope that we will have great event in scale, and probably one and two more AI events in different scale. Thank you very much for attendance. Really appreciate that you spent your time this Saturday with us, and hope that we will have a lot of events regarding to artificial intelligence this year. So I wish you good night, and see you next time.